Zoom recording, and then I suppose you are able to see my notepad as well, right? Able to see my notepad?
Yes.
Okay. So I see all of us are here. Okay, so before we move ahead today, welcome to the last day of our Angular masterclass. And as I discussed yesterday, you have learned a lot in last 28 hours, and those things are very much required and building blocks of Angular. When you start working on Angular, those are the things you need to work on. Those are the things you need to thoroughly understand to build an Angular application. Anything else now you would come across is on top of those concepts. So once again, here I would give you chance that if you have any question, not only from yesterday, even though you have questions from day before yesterday class or any class since the beginning, do ask the questions. Do ask. This is your time to ask the questions. Once again, before I move ahead to the next topic. If you have any question, I would be happy to answer that. No questions? No. All of you. Uh, okay, then we would move to the next topic. Can I ask one question to all of you? Now, are you all confident enough to go and work on a project?
Yes.
Yes.
Mm-hmm. 2 out of 25 people, other people?
Yes. Yes.
So
Yes.
now you are so now you are confident that you can go and work on a project, right? Okay. All right. So today topic is change detection in Angular, and change detection is the most advanced topic of Angular, and we have included that in general training solely for one purpose. Our purpose is that when you go and write Angular application, we expect you not only to write it, but we expect you to write it in a best way. We expect you to understand that whatever code you are writing, what performance implication that could have. I want you to understand that is it possible to improve performance of application by just tweaking some configuration? Is it possible to understand? Is it uh, mm, possible to improve the reusability of our component by tweaking some configuration? And also, when you write Angular application, you really need to understand the underlying compilation process, the underlying process on which actually Angular works on. And the most important of them is change detection. And today, for next 1.5 hours or 2 hours, we are going to get deeper into this topic. And you'd have a lot of questions. You need to be very attentive when I talk about every piece and parts of this topic. You got to ask questions, you got to stop me, and you got to ask me questions. So we are not going to have a lot of visual output of this. We are not going to have a lot of visual output of this topic because this is very much the conceptual topic on which Angular works. So you got to focus a lot. You already have mastered Angular services and dependency injection, and now you are mastering Angular change detection. And by combination of this very conceptual topic, along with those syntax-based topics like how to make an API call, or how to create a reactive forms, how data binding works, how custom directive works, and all those things, you become a good Angular developer. So today we are focusing on change detection. Now, what is change detection? So if I may ask you that what is the fundamental unit of an Angular application? Which part of Angular application your user interact with? What would be your answer? If I ask you, your user interact with which part of Angular application? So in Angular application, you create directives, you create services, you create pipes, you create components. What your user interact with?
Component.
Component, right?
Component.
So component is something your user interact with. And if you look at a component has two major sections. A component has a class, and a component has a template. Right now, a component has a class and a component has a template. Class has data, and on the template you display or display data and capture user interaction. This is the mainly thing which happens between data and template, between the class and the template, right? Now, as you rightly as on the very first day you learned that there are various ways data can flow from class to component. For example, and that is called data binding. You learned about interpolation. You learned about event binding. You learned about property binding. So interpolation, you display data from class on the template. Event binding, you capture the user action from the template into the class. And property binding, you configure, you set property of certain element on template using the data from the class. You have already learned these things. And also you learned that combination of event binding and property binding is called two-way data binding, which is implemented in Angular by ng model, putting that in banana in the box syntax. So you already know that you are already using that. Now, it may happen, right, that if you have a let us say there's a data called data equal to 9 on your component class, and you are displaying that using interpolation, right? So here I'm saying data, and you are getting that output 9. Agree? This is very simple. Like you have data equal to 9 on the class, and then you are displaying that using interpolation, and you are getting data equal to 9. Now, let's say that data has become 19, and could become 19 could be due to various reasons. Maybe data is calling an API, and API is updating that data, or maybe there could be various reasons for that. Maybe user is that component is a child component, and data is coming from somewhere else. So due to any reason, data has been updated from 9 to 99, and still you are displaying that data. Now what you are expecting that your user should able to see 19 when it not 9. Right? So let's say that at 9 o'clock, the value of data was 9 and 9 was displayed. At 9:05, value of data is 19. Now you expect that user at 9:05 should see 19, should not see 9. Now there should be someone who takes this responsibility to make sure that data is always in sync with the template. There should be someone who should take care of this. So there should be someone who is aware of inside the Angular application, who is aware of that, hey, data has been changed. It means I need to go and update the template. Because if you look at our Angular application, what we have written for last 7 days, we are not writing any extra code for that. We are just focusing on writing our component class, writing our logic in the class, and using, let's say, interpolation. Okay, so we are just doing that, and we are not doing anything extra than that. We are writing our logic, and we are expecting that whenever our logic is updating the data, our templates should get updated. And we are expecting that data and templates should always be in sync with each other. That's our expectation is. Now, what I mean by that data and interpolation, data and your data from the business, from the class and template should be in sync with each other. What I mean by that, let me show you with an example first, and then I'll come back to this again. Okay, so here I'm going to show you my Visual Studio Code, and I have here app.component.html, so I'm going to get rid of that. All right, and here what I'm going to do, oh, are you seeing my Visual Studio Code? Yeah. So you're going to see my Visual Studio Code. Now what I'm going to do is, let us say that on my component, there is a variable called, on the component I have, so here in the component.ts, on the component.ts, let's say that I have something called count, and the value of count is 0. Okay. And value of count is 0. And then I have a function here, int count. And what this function does, it increases the value of count. So I'm saying this dot count is equal to this dot count plus 1. All right. And this is very theoretical and very conceptual subject. So I request you focus completely. If you understand it, like out of 100 Angular developer, 95 people don't understand this concept. So be very attentive. Don't go into what is the business use case of that, what is the UI of that. Those things, if you understand that, you'll be able to implement that in any business use case and make that business, make your whole Angular application performance better. All right, so we are going very step-by-step manner. And as I told you that out of 100 Angular developer, 95 people don't understand it. And those 5 people who understand it are called so-called pro Angular developer. So please focus on each line I'm saying. Ask me question, stop me and ask me question then and there. Today I'm not going to follow up with you. Today is the last day. Now no longer you are just an intern on a first day of Angular training. Okay. So if you are not asking questions, I would assume that okay, you understood, you are understanding everything. So today it is your responsibility to stop me and ask me question whenever you think is appropriate. I'm going to go into the flow today. So here I have declared a variable count equal to 0, and then I have a function int count. And in that function, what I'm doing, I'm incrementing that value, this dot count equal to this dot count plus 1. Pretty simple code, nothing fancy about it. Okay. Then what I'm going to do, I'm saying count here in the HTML, sorry, in the component.html, let's say that call it change detection demo. Okay, and then I'm saying that in the H2 display that count, and then let's have a button. Call that button as update count, and then on the click of that button, on the click of this button, we are going to call that inc or whatever function we have created. That function is inc count. So let's call that inc count. Pretty simple code, nothing fancy about it. When we are calling that inc count, when we click on that button, we are expecting that count, that function to be called, and inside that function we are incrementing count value by 1. Okay, so here is the code in front of us, and let me go and run this. So if I can show you my browser, 4200. Okay, so when I do update count, you see that you are getting that updated count. Now here you need to understand something very important, right? I'm clicking on the button update count. It is going to TypeScript, and then it is updating the value of count. And then again, as soon as that value is updated, this on the template, you are getting the reflected value. So always the template is in sync with the class. Here in this scenario, it looks like pretty simple, but there's someone who is taking there, that who is taking this responsibility that whenever value of count inside class is incremented or decremented or rather updated, it is syncing that updated value with the template. And that's the reason whenever you are clicking on this button update count, you are actually incrementing the count value, and there is someone who is making sure that you have the reflected data back. Let us understand this with one more example. So here what I'm going to do, let's say that I have here in the, can you see my Visual Studio Code? So let's say that let, let's say that here I have one, let's say that here I'm saying implements and then on init. All right, and then in on init, we are saying ng on init. All right, and again, and then here I'm using a JavaScript function called set interval. Set interval is a JavaScript asynchronous function, and whatever you write inside that, that will be called on the basis of parameter you have passed in that. So if you pass 10 millisecond and a callback function to set interval, that function will be called each 10 millisecond. So that's the JavaScript. That is JavaScript for us. So here I'm saying set interval, and inside this I'm passing a function, and I'm saying that hey, call it each 10 millisecond. And now here I'm saying this dot count is equal to this dot count plus 1. So what I'm doing here, that each 10 millisecond I'm incrementing the value of count. So try to understand here that on the component, on the class, the value of count has been incremented each 10 millisecond. Here I'm implementing that here I'm implementing that inside a asynchronous JavaScript method, which is being executed each 10 millisecond. That in real-time scenario, that can be implemented from the API call or through the observable and all those things, right? There could be various reasons that this value of count is implemented. The messaging here is that as soon as the value of count is implemented, in line number 15 to 19, I am incrementing that value, and I'm not doing anything to make sure, I'm not doing anything as an Angular developer. I'm not doing anything to make sure that, hey, if this value is incremented, then update my template as well. I'm not doing anything. I'm just following a syntax to display that value of count, which is line number 3 in the line number 3, that interpolation I'm using. And using interpolation, I'm just saying that by following to that syntax, I'm saying that, hey, whenever that value is in, like I'm just saying display that value. I'm even not saying whenever incremented or decremented or updated. So if you go back to your first day of training, interpolation is a one-way data binding, and it displays the data from the template, from the class to template. Now here you need to understand, everyone, you need to understand that the value of count is being increased each 10 millisecond. The value of count is being increased each 10 millisecond. And even though it is being increased in the class, the template is in sync with that. A template always has the updated value. So right now, if I go and run this and show you the browser, so here you see that the value of count is being incremented each 10 millisecond in the component class, and template is in sync with each other. And that's the reason you are getting on the template, you are getting that updated value. All right, once again, go take a step back and understand. We just use interpolation. We are not writing any code as an Angular developer that, hey, if value of count is incremented or decremented or updated, go ahead and update the template. We are not doing that, right? We just use interpolation, and using the interpolation, we are displaying that data, which is being declared and updated in the class. Now in the class, that data could be updated due to various reasons. It could be updated through an API, it could be updated by a button click as we saw earlier, or it could be updated in an asynchronous manner, the way it is being updated right now. And like here, it is being updated each 10 millisecond. Now data in component class is updated each 10 millisecond. and you are getting, and the template is in sync with that, and you see that without refreshing the page, without doing anything, you are getting this updated data right here. So yesterday there was a question that if I open that in a new tab and perform some operation, and it should get reflected in another tab. And that's the messaging I wanted to give you, that your Angular application is capable for that. You have already written code for that using that observable and RxJS stuff. Only thing is that the API which you are using was not capable to push new data to that observable. And since your API was not capable to push new data to that observable was actually doing nothing. So if you need to make an API which can push new data to an observable, that API should be that those type of APIs are called WebSocket. All right. So here you see that I am getting the data and everything is there, right? So far so good, everyone with me?
Yes.
All right. So by now you might have realized that, hey, there's something in Angular which is taking care of that. There's something in Angular which is making sure that whenever data is updated on the class, on the component class, it should be in the sync with the template. There's something in the background which is keep running, and that background task is making sure that data and template are in sync with each other, right? By this time you might have realized that there should be something in the background which is making sure that always my data which is in the component class and the template are in sync with each other. Now, what is that background task? Who is that person? That is the topic we are going to explore in detail today. So let me go back to Visual Studio again. All right, so here I'm in the Visual Studio, app component.ts. And if I show you Visual Studio code, now what I'm going to do, so far so good. Now, what I'm going to do here, okay, what I'm going to do, I'll go to the constructor of this code, this component class. And in constructor, let me inject something called private cd change detector ref. So I injected something called change detector ref in the constructor. And as you know, that constructor would get called each time you create an object of this component. So inside that constructor, I'm saying that, hey, this dot cd dot detach. Okay, just look at that code and we would come back and reevaluate this code again. So what I have done in line number 11, I have injected a service called change detector ref. And then in the constructor itself, there's a method of that on that service called detach. I'm calling that. Also here in shell interval, I'm saying console.log and this.count. I'm just printing that to check whether we are having updated data or not. All right, so what I have done, I am just printing the count value in the setting table, and I'm making sure that I injected a service called change detector ref, and also in line number 12, I'm de-attaching that. Okay, so far this code is clear to you, everyone. Just focus on this line of code, these lines of code for 1 minute before I go back and show you the output. Today is very important topic. I want each one of you to be on your toe. As I am saying, out of 196 developers doesn't understand this concept of Angular. No, they don't. You can go and verify that. So it is to your responsibility to understand. This is the concept which will help you to making performance of your Angular application better. And that's why we are going very step by step. Look at this code, what we have written. And if you have any question, ask me before I go and show you the output. I'm giving you here 2 minutes. Okay, if you don't have any questions, should I move further?
Yes.
Yes.
Okay.
Yes.
So the code is in front of you, and let me show you the output. Boom. You are not getting that value of count displayed here, right? Can you hear me, everyone? Can you hear me?
Yes.
And if I press F12 here
Yes.
in the
Yes.
browser, if I press F12 here in the console, can you see that value of count is being increased? Can you see that the value of count is being increased in the code in the Hi, am I audible now? Am I audible now?
Yes.
Okay, so now can you see in the and you are able to see my browser, right?
We are not able to see your. Okay, now we can see.
Okay, so now let me refresh it again. Okay, can you see now that we are not getting even that count displayed? However, in the console, can you see that the value of count is being increased? In the console, can you notice that the value of count is being increased?
Yes.
Yes.
Now, what happened just now? Now you see that our component class is working as expected. It is value is being increased and everything is happening as expected. However, my template is not in the sync with the component class. Can you conclude by the output which is in front of your screen? Can you conclude that? That now my component class and template are not in sync with each other. They don't know each other anymore. Can you see that? And that's the reason that the value of count is now 5,610. However, on the template, that count is even not displayed, right?
Yes.
And what one small piece of code we did. If you look at my Visual Studio Code again, and if you look at line number 12 and line number 11, what I done, I injected something called change detector ref in the constructor of the component, and then I attached that change detector ref. So change detector ref is a service like any other service, and that has a method called detach that has many other methods. I call that detach. Now you can you conclude that by looking at that code, line number 11 and line number 12, that if that change detector ref, if object of change detector ref is not attached to a component, the component's template and component's class is not in sync with each other. Can I say that?
Yes.
I repeat, can I say that if change detector ref of an object of so change detector ref is what Angular is going to do, it is going to create one object for each component. So it is the way it is provided that each time you provide it in a component, it is going to create one object of change detector ref for each component. So if there are 100 of components in your Angular application, there are 100 object of change detector ref. So that keep in mind, okay? Now for this particular component, what I have done is I injected that and then I deattached that. It means I'm telling Angular that, hey, don't use change detector for this component. I'm telling Angular that, hey, do not use change detector for this component by line number 12. And when I instructed that to Angular that, hey, do not use change detector for this component, Angular is saying, okay, super fine, go. Do whatever you want to do. And Angular is not taking care of making sure that my template and my component is in sync with each other. Everyone getting what I'm saying?
Yes.
So can I say that this change detector is the person, or change detector is the code, or change detector is that background task, which is making sure that always my template and my component class are in sync with each other? So there's something called change detector. The change detector is nothing but a service. Each component has its own change detector, and the job of change detector is to keep running in the background and make sure that your template and your component class are in sync with each other. I repeat, in Angular, every component has a change detector, and the job of change detector is to keep running in the background and make sure that the template and component class are in sync with each other. So by any chance, if you remove that change detector, or you do something, you deattach that change detector or anything, Angular will not then change. So in this case, we have deattach change detector. Means we are saying that, hey, Angular, do not run change detector for this component. And since we are saying that to Angular that, hey, do not run change detector for this component, Angular is not running that. And as an output, we do not have our template and our component class in sync with each other. So change detector is responsible to make sure that your component class or template in sync with each other. Is it clear, everyone? And each component has its own change detector, and change detector runs in the background. So if I go and write it for you, that change detector makes sure that component and components class and template are in sync with each other. Every component has its own change detector. Change detector runs in the background. Any question on those three statements, gentlemen and girls? Everyone, now you're able to understand those three statements?
Yes.
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 And roughly you can understand it like this, that if a component does not have change detector, or if somehow component change detector is messed up, then the template and class would have to be in sync with each other. Am I making sense, everyone?
Yes.
So far, if you have understood it, let us go further. And what I'm going to type, please read that very, very carefully. Please read that very, very carefully. Okay, everyone? Focus on the screen. Change detector makes sure that components class and template are in sync with each other. We saw that. Every component has its own change detector, and you inject that if you need to work with that. Change detector runs in the background. Now, when change detector runs, we do not know. Means when your Angular application is rendered in the browser, when change detector runs, we don't know. Means Angular doesn't tell us that when change detector runs. So it's keep running, whether it runs each second, or whether it runs each 10 second, or whether it runs each 100 millisecond, we do not know. And we cannot configure that also. So when change detector runs, we do not know. Is it clear, everyone? But if one of these things happen, change detector will surely run. What I mean by that, that when change detector runs, we do not know. But if one of these three things, I'm going to write what are those three things. If one of these three things happen in your Angular application, change detector will definitely run. So let's say that when Dhananjay will come to Ahmedabad, you don't know. Sometimes I can come to each month, sometimes I can come to each week, sometimes I can come to each year, and you don't know when I would come. But you know that if you call me in time of Navaratri, I'll definitely come. then and there, exactly same time I would come. If so there are certain conditions. If that happens in your Angular application, change that detector run then and there. And otherwise you do not know when change detector runs. So whenever in your application you perform an event or raise an event, it means you click a button and those kind of things. Whenever you do this kind of thing, like whenever there's an event raised, there is an event raised, Angular will make sure that change detector runs there and there. Now, you remember on a very first day I told you which type of events. The events which are part of events which are part of ng zone. You recall from the first day, ng zone, everyone?
Yes.
So whenever there's an event raised in your application, which is part of ng zone, change detector will run. I repeat, whenever there's an event raised in your application, which is part of ng zone, your change detector will definitely run. That is one. Second is, whenever you make an API call. Now, when I say you make an API call, this is very interesting, okay? Uh, in Angular, we use HTTP service to make an API call, which you saw yesterday or day before yesterday, I guess. That we were injecting that inside a service, private HTTP colon HTTP client, HTTP client, and then we are making call to we are using that to make call to the API. However, that HTTP client or whatever you are using that internally gets converted to something called XML XHR object. That internally gets converted to XHR object. Now that XHR object is part of the browser. And it is the browser which makes sure that whenever you call an API or whatever you call which is outside that browser, that XHR object calls for that. So you really do not need to understand what is XHR object. That you don't need to. You focus on HTTP client, which you already learned. So whenever you make an API call, that XHR object comes to the action and it does something for you. So whenever that XHR object comes to the action, or roughly you could assume that whenever you make an API call from your Angular application, change detector will run. And that is the reason we should not make an API call in the component, because each time component will be rendered, you will make an API call and then change detector will run. Hence, it will performance of your application could not be better. But if you put that XHR call in the service, at least that XHR object is shared across multiple components. All right. So first, whenever there's an event in your application, whenever you raise an event in your application, Angular will make sure that change detector runs. Whenever you make an API call, Angular will make sure that change detector runs. And the third is, whenever you execute a asynchronous JavaScript functions such that we just use that set interval. So whenever one of these three happens, that an event being raised or an API being called, or you are using asynchronous JavaScript functions such as set interval, change detector runs. So these three things once again are that when change detector runs, so and a change detector runs when an event such as click or submit gets fired. A change detector runs when an XHR is called to work with an API, means when you are calling an API, and whenever asynchronous JavaScript functions such as set timeout or set interval get executed, change detector runs. So Angular assumes that. Now, why change detector runs in these three scenarios? Because if you perform these three scenarios, Angular assumes that data has been changed, and if data has been changed, Angular assumes that the template has to be re-rendered with the updated data. All right. So if one of these three things happen, once again, if an event gets fired, if a XHR or an API, if you are consuming calling an API, or if you are executing a asynchronous JavaScript function such as set timeout, set interval, change detector will run. So is it clear, everyone, when change detector runs?
Yes.
Yes.
I want you to note down these three scenarios because I'm going to ask you questions on this further in the class. So please note down these three scenarios on your notepad. I repeat again, when an event gets fired, when an API gets called, and whenever an asynchronous JavaScript function such as set timeout or set interval gets executed. So once again, you do not know when Angular change detector runs, but if one of these, either all three or two of them or one of these happens, change detector will run. Now, what is change detector? Change detector is a part of Angular which makes sure that your component and template are in sync with each other. Okay, and change detector keeps running in the background. When it runs, you do not know, but if one of these three happens, change detector will definitely run. So far, so good, everyone.
Yes.
Yes.
Okay, give me a moment. Hmm. Mm. Uh, can you see my PPT?
Yes.
Yes. Yes.
You can see the PPT, right, everyone? So the change detector detects the component for the data change and re-render the view to project the updated data. This slide should be clear to you. What change detector does? It does two things. First, it detects if the data is changed on the component class. And if data is changed, it re-render the view to project means display the updated data. Everyone's clear about this slide? The change detector detects the component for the data change and re-render the view to project the updated data. Okay?
Yes.
Yeah.
Yes.
Now every component has its own change detector. We talked about that. Like every component has its own change detector. So if you have 100 of components in your Angular application, there are 100 change detector. All right. So every component has its own change detector. Now Angular runs change detector. We just discussed that. An event such as click and submit gets fired. XHR call to work with an API means when you consume an API, or Angular change detector gets called, and asynchronous JavaScript functions such as set timeout or set interval get executed. So if one of these three things happen, Angular makes sure that change detector gets called. Okay. Now, this slide is very important, which you need to understand. If you have understood what is change detector, if you understood each component has its own change detector, and if you have understood that change detector gets called on those three scenarios. Now, an Angular application is nothing but a component tree. Your Angular application can have 100 of components, and if you put them together, you'd come up with a tree. There is a root component, there is a child one component, there is child two component, then there should be further child one component, child two component, then further child one two component, and so the whole Angular application, you can visualize them as a component tree. Okay, it starts with the app component and so on. So whenever there's an application in front of you, go and draw the component tree for that to identify how change detector works in that, and then you can optimize performance of that application. So you can visualize the Angular application as a component tree. Okay, if Angular application is a component tree, right, and let us assume that user clicks a button in the leaf node. So there is a component A, then component B, component C, component D, component E, component F, all they are children of each other. And now user clicks a button on the on the bottommost component, on the childmost component. Okay, so as you see that user clicks the button, now what happens? And they start running the change detector from the parent component. This is very important, and you really need to understand that. So if there are hundred of components in your Angular application and user clicks a button on the childrenmost component, even though it clicks the button on the childrenmost component, the Angular starts running change detector. So it will run change detector very first of the root component, and then further of the child components, then further of the child components, and then it will come back to that component. So what I'm trying to tell you that this change detector is very expensive operation. So here you are clicking the button. Here you are clicking the button of the childrenmost component. The childrenmost components. So there are hundred of components in your Angular application. You click the button on the 99th component, and still in the default scenario, Angular is going to execute change detector for all those 100 components. You are getting what I'm saying here?
Yes.
Yes.
And this is what we are learning, that how we can avoid that, how we can only run change detector for the component or the child or the children set which is required. However, we do something that if a component is, if there's a click in a component, we need to find out that how minimum component change detector runs. If you are able to, so let's say there are 100 components in your Angular application and 100 change detector runs. But if you are able to manage that on a click only 50 change detector runs, of course, performance is better, right? Agree?
Yes.
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 And we are going to find out how. So here, if I go back again, that an Angular application is nothing but a component tree, and you see that a user clicks a button on the bottommost component, and how Angular starts is goes to the root component, the parentmost component, then the child component, then the child component, and then the child component, and it actually goes from top to bottom. So change detector works in top to bottom approach. Now we are not very sure whether it goes to the breadth first approach. What I mean by that, that no one is sure that whether after root component Angular is going to run the change detector of child one component or child two component. So there's no algorithm to find out. It can go parallelly. It can first run child one component and then it can go run child two component. We do not know. But we know for sure that it will never happen that Angular has run change detector of CC11 before child component 1, or it has ran change detector of child component 1 before root component. So Angular never runs change detector of children before its root. All right. If there are siblings, we do not know which siblings change detector will be executed first. What I mean by that, whether child component 1 change detector would be called first or child component 2 change detector would be called first. We do not know that. However, we are very sure that root component change detector will be called before child component 1 change detector, and so on. So always it goes to the top down bottom approach, top to bottom approach. Okay, so this is the approach it follows. Now, this slide is very important, and I hope each one of you would understand that. All right. So Angular perform. Now you may think, right? If you go back to the previous slide, you may have a question that, hey, this is really bad. There are thousands of components in my Angular application, and out of 1,000 components, just at one place, user is clicking a button, and then Angular is running 1,000 change detector. This is not done. This is going to be very bad for the performance. That may come to your mind. Agree, everyone?
Yes.
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 Right? That must be coming to your mind. So it is not, I mean, it looks like that performance should be that bad, but it is not bad. Why? Due to some design principle, and that is on the next slide. So, and I'm going to read it out for you and then we'll discuss it. That Angular component tree is a directed graph. What does it mean? It is a directed graph, means it always goes from top to the bottom. It may never happen that it will go from, as I discussed with you, that it may never happen that it is randomly running change detector of children one and then children two and then going to the root component. No, it never happens that. So it is always a directed graph. Means Angular knows that after root component only I need to go to child one component. And always a directed performance traversing a directed graph is much better in the performance than traversing a undirected graph. If you go back to your engineering or MCA or BCA, you may have learned that in data structure, that a directed graph, performance of a directed graph, traversing a directed graph is much good in performance than traversing a non-directed graph. So Angular component 3 is a directed graph, which means there is a unidirectional flow of change detector from root to bottom. We just learned that there is a unidirectional, means change detector runs only in one direction, and that also from top to bottom. Angular knows in which direction tree has to be traversed, and there is no circular or bidirectional traversing of the change detector tree. That's very good point, right? Since Angular knows that it always has to go in one direction from top to bottom, and that also in a directed graph, and Angular never goes in a circular traversing or bidirectional traversing. So by default, performance of that graph is much better. I'm not sure how many of you have done Angular J, which was the earlier version of Angular. They had this mechanism of bidirectional traversing, and that had a lot of issues in that. But here you do not have that. So that is one thing. That is the reason. Even though it looks like that 100 component change data is going to be executed, the performance is much better. So the first line should be clear to you. Second is, after a single pass, change detection tree gets stable. So once Angular has done and rendered everything, the next time it just has to go and detect the change. If it doesn't detect the change, it does not re-render that component's template, and it goes to the next template. So once the first pass is done, it is very fast. And the third point, which I just told you, that unlike AngularJS, in Angular, there's no generic function to update the view. So in AngularJS, in the earlier version of Angular, there was one function. So every views was going to the one function, and that one function was taking care of updating the view. However, as we just saw that in Angular, we do not have one centralized generic function. Every component has its own change detector. So that change detector is, we can, as you saw, we can deattach that change detector. We can improve the way that change detector is behaving and all that. And since here is very component has its own change detector, JavaScript virtual machine can optimize it for better performance. So even though it looks like that there are 100 change detectors going to run for one click, due to these three design guidelines, it is much better in performance than its counterparts. Okay, any question on this slide, people?
Hello, sir.
Yeah.
So if we detach the change detector from the app component, then is the child's components change detector will run or not?
Good question, and hold on this. I'm coming to that. We are going to have demo on that. Okay, but good question. It will get answered by end of the class. Okay.
Sure.
Yeah. Good question. Next question.
One question, Dhananjay. So you said like a chain detectors start from root to the bottom, right?
Bottom. Yes.
Yeah. So whenever we click on a button of the child component, it start from root and then it's go till the bottom. So in your previous graph, there were there were two child, right? Child 1 and child 2. If I click on CC211, it actually start from root and go in child 1 as well as child 2, right? It will all the components
in default scenario, but we can configure that.
Yeah, in default scenario.
Yeah.
Even though I have clicked on CC211,
it will go and run change detector of the whole application.
All the child component, right?
Yeah.
So if I click a button on a CC22, it will start from root and go till the C121 and CC211, right?
Yes. in the default scenario, and we are going to learn how we can avoid that.
Okay. So any child component you click, it will traverse the whole tree.
Whole tree, the whole Angular application in default scenario.
Okay.
If you have not done anything, just writing component and doing that. But
Okay.
definitely we can avoid it, which we are going to learn next.
Yes. Yeah. Okay.
Okay. But in default scenario, yes. Okay, good. Next question. Should I move
Sir,
forward? Yeah, go ahead.
if we click the button and C211, and so the change detector of root component, child component, CC21, and all this call. And
If you click button of which component?
CC211 at the bottom.
Okay, yeah. Then
so the whole tree's change detector is performed. Okay.
yes.
And by that clicking of CC211, some parent component's data value is also changed. That is managed in HTML and PS both. So second time the change detection is also done or not? Are you getting or not?
No, can you explain your question again?
So the child components click is done. So the change detector of all root.
So let us go step by step. Let us go step by step. You are saying you are clicking a button on CC211. Okay.
Yeah. Yeah.
Okay, that is a step one. Next what?
So the change detector of all the tree is performed.
In default scenario, yes. Yeah.
Yeah. And by clicking some CC211's component.
So again, wait. By clicking what?
CC211.
Yeah, you click that only. Yeah.
And it emits some event and the value is changed in CC21.
Okay, so it emitted an event and value changes in CC21. Okay.
So the second time also the whole tree is configured or the detection work.
No, but it will not go to the second time. That would happen in the first time only, right? Because on that, so to emit something from CC211, you need to click a button or you need to perform an event, right?
Yeah.
So as soon as that event is captured, Angular will start running the change detection key. And by that time, Angular will reach CC21. It will have the updated data to render.
Okay. But it only emits the event. Okay. The data is changed in parent component.
Yeah, that is fine. That's what I'm saying, right? Like, let's say that okay, I understand your question. Let me explain. Let's say C211, there's a button, and that button is emitting an event, and that event is going and changing data equal to 9 in CC211, right?
Yeah.
Right? Now, as soon as you click that button, whatever you have done in that button, Angular doesn't care about that. Even if it is an empty button, empty click, Angular will run the change detector. But from where Angular will run the change detector? Angular will run the change detector from root component, then child1 component, then child2 component, then CC21. And when it will reach CC21, now it has the updated data, right?
So my only concern is that it only emits an event. So it basically calls the function of parent component. The data is not changed yet. Only the method calling is done yet.
So how Angular works?
Is it changed thing or not?
No,
the data is changed?
I'm not able to understand your question, to be honest, but let me explain you something. Angular does not care about whether data change or not. Angular, Angular does care about data change or not. How data has changed, Angular does not care about it. So let's say that at any given point of time, change detector for CC21, it will go and check whether any data is changed in that component or not. Whether it is changed through event emitter or whether it's changed through wherever, it does not care about. If that is changed in default scenario, it will make sure that template is re-rendered. Am I answering your question, or am I not able to understand your question?
Okay, the one part is clear. And if it emits an event, okay, but before emitting an event, CC211.
Mhm.
Before emitting an event, it also changed its data somehow. Own components data, and then it emits an event to parent, and then parent's data is also changed. Then the 2 times change detector is performed or 1 time only.
No, okay. That's what I told you. How many times change detector runs, we do not know. You remember I very explicitly told you that just like 10 minutes back.
Yeah, but
You
here
recall that?
data is changed 2 times, so that is my
It doesn't work. It doesn't work
doubt.
that way. It doesn't work that way. How many times data is changed? Only if those three scenario will happen, then definitely change detector will run. Change detector, Angular does not run change detector only when data is changed. Keep that in mind. Angular has no way to know your data is changed. Angular only knows the data is changed when it runs the change detector. When data changes, then change detector runs is not true. When change detector runs, then it identifies whether data changes or not.
Okay.
Making sense?
Understood. Yeah.
So Angular, when Angular runs change detector, we don't know, as I told you. But if one of these three scenario will happen, then definitely change detector run.
Okay, understood.
Right? So it is not that if data is changing, then change detector is running. No, change detector is actually running and identifying whether data is changed or not. And if data is changed, then it is re-rendering the view. Okay, so you are satisfied now?
Yeah.
Okay, more questions, please. Very good discussion. Yeah, I want questions like this. Keep them coming. Come on. Interns, 2 questions more. No questions? No questions? Should we move further?
Yes.
Okay. So, as you said, that our whole purpose is, this is a tree in front of you. By default, these are the design guidelines in front of you by default. Now, our whole purpose is reduce number of checks. When I say reduce number of checks, means it should only run for the minimum number of component. And if somehow we are able to reach that, I'm not running a change detector. And the gentleman who asked this question, if you think your question in a little bit different way, right? I'm telling change detector that, hey, don't run, please don't run. However, when data changes, change detector doesn't know about that, but I may know about that, right? When data changes. So when data changes, if at that point of time, I request Angular to run the change detector, we can improve performance a lot, right? So let us understand an example. You made an API call in the subscribe method. You know that data has changed. Yes, everyone? So assume a scenario that by default, I'm telling Angular that, hey, do not run change detector for me. It's okay, thank you so much. But whenever data changes, I can know in my business logic that, hey, data is changing now. Let me request Angular to run change detector. And in that way, we can reduce number of checks. And there are various ways to reduce number of checks. I just taken one example. So the whole idea is to write a better performance Angular application is to reduce number of checks as much as possible. When I say reduce number of checks, means reduce number of change detector running for per component. So assume that right now, if you go to the previous slide here, change detector is running for the whole component tree. If by any way I'm making sure that, okay, if for that click event, I'm making sure that change detector is only running for what you see in the right hand side, like app component, another child component, CD, and CD. And because I know that that particular child is child of that subtree, and it has nothing to do with the other subtree. So there's no point running change detector for other subtree. So if we can achieve that, if we can achieve reduce number of change detector runnings, if we reduce number of checks, our application performance would improve. Everyone agree with that? Yes.
Yes.
Okay. So how we can do that, right? Now we can do that using change detection strategies. There are two change detection strategies. One is called default, one is called on push. So if you do not do anything, you are working with default change detection strategy. But if you want, you can change that to on push change detection strategy as well. So if you have not configured it, by default, that is default change detection strategy. And if you, otherwise you can configure that to on push. Now, what are the differences between these two? When to use what? I'm going to explain it. But here is the major difference. So change detection, data changes to the input decorated properties, the default change detector will run. So let's say there's a component, and then that component you are passing the data using input decorated property. If that data changes, change detector runs. So since first day we are passing data using input decorated property, we are getting the updated data, and everything is working fine because we are working with the default change detection strategy. All right. But if you, for a component, if you have on push change detection strategy, then in that case, for the input decorated properties, if you pass new object, then only change detector will run, otherwise it would not run. So if you are on the default, change detector will run whenever data changes in one of the input decorated property. However, if it is on push, change detector will run whenever you pass a new object to change detector to input decorated properties. Okay, in default, any data. In on push, new object. And of course, besides these 2 points, like passing new object or passing input decorated properties, if one of those 3 things happen, change detector will definitely run. So even though you are on the on push, okay, even though you are on the on push input decorated on push change detection strategy, and you are not passing new object, means change detector will not run. But if you perform one of these 3 operations, like clicking an event or making an API call or executing a asynchronous JavaScript methods, if one of those 3 happens, change detector will definitely run. So keep in mind that those 3 are the most powerful and have the highest priority. So if one of those 3 happens, change detector will definitely run. Okay, so again, you have created a component and put the change detection strategy to on push, step 1, and you are not passing new object, which change detector should not run ideally. But if you do one of those 3 operations, clicking an event, raising an event, or clicking or making an API call, or executing a single JavaScript function, change detector will definitely run. And I'm coming and I'll show you all this in the code in a bit. But you are getting the message what I'm trying to give you here, right? So if you have a component and component has input decorated properties, and if the change detection strategy is set to default, whenever any data changes in any input decorated properties, change detector will run. Now, if you have set change detection strategy to on push, and you have input decorated properties, in that case, change detector will only run when you pass a new object. If you do not pass new object, change detector will not run. And in both scenarios, change detector will run if you do one of those 3 operations. This slide clear to everyone?
Yes.
Yes.
Yes? Okay. So let us see those change detection strategies in the action. So here you can see my Visual Studio Code. Okay. And in Visual Studio Code, how we can reduce number of checks. So what I'm going to do, I'm going to add a component here, in the application. I'm calling it as, can you see Visual Studio Code, everyone? Can you see Visual Studio Code?
Yes.
Yes.
So here I am saying count component.ts and saying export class count component, and then we will decorate that with component component. Okay, then selector, let's say app count, then it has template, let's say template. Okay, and I'm going to create a template right here. So we are saying const template equal to this, and in this count component we are going to create some data. So here we are saying at a rate input, and that is counter. Okay, so here we are saying input and counter, and then there is constructor. The constructor, we can say this, or better we'll make it counter as any, and then here we'll say ng on init, and that is void, and we can implement on changes, and let's say that we have ng on changes here. Pretty simple code, nothing fancy. You already know about it. You have seen this code before. And then we can say here template count in child equal to counter. Yeah, it is correct now, right? So we are saying count in child counter. We are displaying that. Now to use this, first we need to take that count component to app.model.ts and first pass it in the declaration. So we'll say count component, and once this is passed, and then we can take this app count gentleman from here and go to app.component.html, and let me, as of now, let's use that app count. Okay, then we have button click increment count, update count. We are there, and here in the app component, what I'm going to do in the app.component.ts, let's go here. As of now, I am commenting this, and then I'm getting rid of that. Also, I'm making sure that I don't have this here. So I'm just reversing back to the default, how it should be. Okay, so here I'm saying creating an object, we are saying counter, and in that counter, the count value is 1. Okay, and then in increment count, we are saying this dot counter dot count equal to this dot counter dot count plus 1. So we're incrementing that, and then here we can pass that counter. So let's go to this. This is counter, so we need to pass that. So here we'll say app.component.html counter, and then here from here you can pass this counter. Okay, and then count.html, it will have counter dot, it will have counter dot count. So it has come. Okay, pretty simple. I created a child component called counter component, implements on init and on changes. It has counter value any, constructor ng on changes, and then we are displaying that count in child counter that child. Then we have declared it here. App.component.ts, there's a function to increment count, and there's an object counter equal to count1, and app component.html, we are calling that and then passing that. So it looks good, and let's see that how our application works. So here in the demo, you can see that change direction demo count in child is equal to 1 by default, update count, and you are getting that value. Now what is happening that what is happening here is that our change detector for the component is set to the default strategy. Means whenever there is a data changes, whenever there is a data changes from the parent component, whenever data changes from the parent component, yes, in one of the input decorator property, it is updating, it is making the change detector of count component is running, and then it is making sure that the template and the component class is in the data in the component class is in sync with each other. And that's the reason when we click on this button, update count, that button is on the parent component and the data is changed in the parent component. And the updated data is passed using input decorator property, and you are getting the expected output. All right. So let me go and show you the Visual Studio Code once again. Now in Visual Studio Code, let's go to the count component.ts, and here, what if I say change detection and change detection strategies, and there are two change detection strategies, that is one is default and one is on push. Here we are changing that to on push. So now what I have done, I changed the change detection strategy to on push, and then I say save, and I'm here, refreshed it, and if I show you the browser again, we refreshed it and changing the browser, you see nothing is happening. If you look at the console there, let me show you that console.log this dot counter.count. Okay, so now here press F12 and update count. See, we're getting so the data is updated in the parent component, and that updated data is passed to the child component. But child component template is not in sync with that. What does it mean? That for some reason, change detector of child component is not running. You agree with that? Yes, no? You are able to hear me, everyone?
Yes.
So we have updated data in the parent component, but what we have done in the code, we want that, hey, just don't run the change detector whenever data changes for count component. So I have made it on push. I have made it on push. And what is on push? What on push says? On push says that a change detector for that component would run when you pass new object to that component's input decorated property. Here we are not passing the new object. What we are doing? We are just updating value in existing objects. So if you look at the code here in line number 17, that line is not creating new object. Instead of that, what it is doing, it is updating, it is just mutating the same existing object. So even though state of the object is changed, Angular is not running change detector of child component because we are not passing the new object. Is it clear, everyone? Because the default strategy, the change detection strategy is set to on push. And if change detection strategy is set to on push, it means only change detector would call when you pass new object to it. Clear, everyone? Yes, no.
Yes.
You have to talk to me.
Yes.
Also try to understand one thing, that so like let us say now there is child one component, there's something called count child one component, then count child two component, and so on. If change detector of count component is not running, it would make sure that change detector of all its child component is also not running. So if you go to the PPT again, and this is very important, you need to understand that on your screen, you see, right now on your screen, if you see, can you see my slide on your screen?
Yes.
Now what I have done, I have changed the change detection strategy of count component to on push. And from app component, I'm not passing new object to count component. So the change detector of count component is not running. And also it is making sure that change detector of all the child components of count component is not running. So it's like this. If you avoid running check for one component, all its children will also not get executed. And this is the way, just by changing the strategy of one default strategy, of default to on push strategy, I have reduced the number of checks for this tree almost by 50%. Now, if you want to map it to the real-time scenario, that when this would be useful. Let us take a real-time scenario where I'll map this, and then you would understand that how that could be very useful for you. So assume that you have a component. And when you see my OneNote, let me know.
Yes.
Okay. Now go back to all our learning of a smart component, dumb component, and everything else. All right. So let us say that I have a component here. So I have created a component. This is my main app component. Of course, there should be one main component, and you cannot put this main component on push. So this is my app component. So this is my app component. Okay. And inside this app component, I have let's say inside that I have a product component. I have a product component. And this app component is passing data to the product component. So from here, we are passing data. And let's say that we are passing products. And be very attentive, everyone. So this app component is making a call to the server API, whatever it is doing, and then it is getting a products array. That products array has 100 of rows and it has 10 columns, means there are 1,000 data point in that products array, and then it is passing that to the product component. Okay, now what product component is doing? It is getting that data in a input decorated. So the product component is getting that data in an input decorated property. So here it has an input decorated property called products. So what is happening here using from the app component that is being passed to the products. All right, so now this product component is kind of a smart component in this way because it is getting data from app component. It is also a dumb component in context of app component. But for this example, we can say it is a smart component because further it has subcomponents. Like this. Okay. Now what this product component is doing, it is just passing that. So let's say that it is a grid P component. Then it is list. It is grid P component. Then you have here, let's say that list product component. And this is, let's say, another third component called ABC component. And all these grid component, list product component, and ABC component is getting data from, so product component is taking that data and just passing them to these three. All right. So these are the display data only. Now this app component has one more child component right here. And in that child component, it is editing that product. Okay, means to edit that product, an event should be raised, like key press event or something like that. So there are 1,000 rows and columns, which is being here user, and this app component is passing data here also and from here also. Now this is your component. This is your component tree, a kind of component tree. Now in normal scenario, what would happen in a normal scenario? Like forget about on-push strategy. A user will start editing something right here. A user will start editing something. A user will start editing something here. It means there are 1,000 data points, right? Like because there are 100 rows and 10 columns. So that 1,000 data points, user is editing that. Now to edit that, user is doing some key press event. So if an event is being raised, change detector will run. Everyone with me?
Yes.
So there are 1,000 scenarios that that user is just pressing that, and let's say that there is a save button here also. So whenever user has done editing, then user need to click on the save button such that this data get reflected. This data gets saved. Now in normal scenario, what is happening that as soon as you start raising, the user is pressing that event, the object which is being used here is getting updated. One of the value in that object is getting updated. You are not creating a new object. You are just editing that the way we are edited in this .counter.count. And the data is passed from here, means one of the value has changed inside the same object. The app component will pass that data to the product component. Now product component sees that it is on the default strategy and sees that, okay, one of the values changed. It will run the change detector of its own, and it will run change detector of all its child component, grid component, list product component, and ABC component. There could be multiple problem of that approach, but one problem for sure, which we are discussing right now, that for each user key press, 4 change detector is running. But we want this grid product, list product, and ABC product to display the product only when that has been saved, not in the real time when user is editing. Am I making sense here? Now in default scenario, how would you avoid that? You cannot. I mean, if you don't know change detector, you can start writing 1,000 lines of JavaScript to avoid that. And they would say that it is very complex problem. But What if I come to this product component and say that, hey, change detection for this is set to on push. It means I'm saying that, hey, you can go only to me and my children when you pass new object to me. And when user is doing something and editing something in line on that edit product component, you are not creating new object. You are allowing user to edit. Once user has done the editing and user clicks on this set button, now you know that data is in a state which need to be reflected everywhere. Then you create a new product array object. And when new object is created, new object will be passed to product component, and then its change detector and all its children's change detector will run, and of course it would have and for them would have updated data. So you see how can increase performance of your application. Are you able to map that? Everyone got the use case?
Yes.
You do not want, let's say that this is one edit scenario, right? But let us assume that this app component is keep calling API each 10 milliseconds. And it is keep calling API for the updated products array. And API is not returning updated products array, it is returning the same array. In default scenario, in default change detection strategy, what would happen? Each time that API is being called, even though product doesn't have updated data, it will come back and run change detector of product component, run change detector of grid component, list product, and ABC component, and so on. But if I put product component on push change detection strategy, then even if it is calling the API each time, we are not, this whole subtree of product component is not caring about that unless and until it is not passing new object to it. And if it is passing new object, then product component is sure, okay, it means there is some updated data and I need to pass it to my children such that they have the updated data to render. Am I making sense, everyone? Yeah. So is it making sense, everyone?
Yes.
So here I'm going to give you 5 minutes to look at this image which is in front of you and think how can even, what are the different ways you think you can improve it. Just think about it. Okay. Any questions? Should I move further? Should I move further, class?
Yes.
Okay.
Yeah.
So here, let me share Visual Studio Code again. Okay, so now, as you see that right now, once again, just to revise, we have put it on the on push, and then it has an input decorated properties counter. And then from app.component.ts, we are increment count. We are just incrementing the value of the property. We're not creating a new object. And that's the reason when we are running this application here, when we are running this application and then update count, the count is being updated, but we are not getting updated template, the data in the template for obvious reason, because new object is not being passed. So one way to solve this is we'd go here to app component.ts, and instead of saying this.counter.count plus one, we can say this dot. So we can create a new object equal to, and here we can say this dot. Here we can say count so here we say this dot counter is equal to count, and then whatever is the value of counter, this dot counter dot count plus one. So if you look at now what we are doing, we are creating a new object. In line number 17, we were not creating new object. Line number 18, we are creating new object. And since now new object is being created, let's go to the output here. And if you look at the output, new object is created, and run this again. And you are getting the expected output. So now you know that in one push change detection strategy, change detector for that component and its subtree only runs when you pass a new object in one of the input decorated property. And I gave you a real business case that when you need to do that. So it may happen that you are passing a large set of data from one component to the child component. And you know that large set of data could be changed from anywhere else. If it is on the default, then what would happen that if any value in that large set of data changes, let's say that you are passing an array which has 10 rows and 10 columns to a component in input decorated property. Now, if any of those 10 rows / 10 column value changes, what would happen that Angular will run change detector for the component where you are passing it and all its child component. You may want to avoid that because it's so large set of data that you only want to run change detector when you are very sure that if data is changed. You don't want to run it randomly on any value change. So for that, you set the change detector strategy to on push. And then you make sure that from the server, you are passing new object. Okay. So this is the way you can achieve on push. Now, let me ask you a question. Let's say that here is a question on your screen in the notepad. Can you see my notepad? So let's say that for the count component, the change detection strategy is set to on push. And add component is not passing the new reference component. So let's say that here we went and changed, but app component is not passing a new reference or object. So the scenario is for the count component, the change detection strategy is set to on push, and app component where you are using the count component, it is not passing the new reference or object to the count component. Now, how would you make sure now you need to make sure that Angular runs the change detector for the count component and updates the view. How will you achieve it? Question is in front of you. For the count component, the change detection strategy is set to on push. And at right, just in the demo, we passed a new object, so it is running that. But let's say that we do not have control on the app component. It is saying that, hey, I will not pass the new reference. It is not passing the new reference to the count component. Now, how would you make sure that Angular runs the change detector for the count component and observes the view? How do you achieve it? What my question is, if I show you in the code, so here in the code, my question is that, let's say we do not have this code, we have this code, okay? It means that when I go ahead and run this, of course, we are not getting the updated data. Now I need to get the updated data here. What should you do? What comes to your mind? The question is right now in front of you. Think you know the answer. Think answer is there on the notepad itself. Answer is right there on the notepad. You are able to hear me, everyone?
Yes.
So if you look at the notepad, I hope my notepad is here with you. Yeah. So if you look at the notepad, here's a question, but answer is also right there. Come on, every interns.
We need to raise one of those three events.
Perfect. That's the answer, right? What I told you, regardless everything, whether it's on push or default, whether you are passing new object or you are not passing new object, regardless everything, if one of these three happens, means you raise an event, you make an API call, or you execute a synchronous JavaScript function such as set interval, Angular will definitely run the change detector. All right. So if I go to this code here in Visual Studio Code, if I go to count component.ts, and let's say that here I'm saying button, and this button is, let's say that refresh child, and in this button I'm saying a click, and that click I'm not calling anything. That click is actually just, let's go and put a 0. That click is not calling any function. So here I have a refresh child button. Okay, now let's go to, so here you see that I am in the browser. You're able to see my browser, right? Yeah. So I'm in the browser. Here I'm saying update count. So the value of count is 13. Update count, value of count is 17. I click on refresh count. See, I got 17. Means change detector ran. Again, I do update count. Count is getting updated. Then I say refresh child. I'm getting 31. Because when I click on that refresh child, change detector is run. So you might have seen many applications where you might have thought that, hey, why they have an explicit button for refresh the data and something? Because just by asking user to click one extra button, they might be improving performance of application drastically. Right? So let's say that I don't have control on the app component in this scenario, means I don't know how that app component is going to send me the data, whether it is going to send me new updated object or it is going to send me the same object. I do not know that, but I want to improve performance of count component and all the child component inside count component. So for that, what I did, I put the change detection strategy to on push. That is the first thing I did. I put change detection strategy to on push. And then I have put up what to say button, and when I click on that button, it is refreshing the page. It means it would run the change detector for all the parent component and the child component further, and we're getting that. So this is the one way you can achieve little bit of performance and work with on push change detection strategy, even if the parent component is not passing new object. Is it clear, everyone?
Yes.
Yes.
Yes, no?
Yes.
Now, there's some challenge in this approach, right? So let's say that I am here, data is not updated, and you just keep clicking refresh child. User can do that, right? So as many times I'm clicking on this refresh child button, I'm running the change detector. And my data is not updated, but still I'm clicking that and running the change detector, right? I updated count, and then again I'm running that it is getting. But you see that I don't have updated data. I'm clicking on refresh child, means I'm running the change detector. So that is a challenge. User can keep clicking on that button and your change detector is running for no reason. How we can improve it further? So far, whatever we have done has some challenges. So challenge number one is, okay, I tell you that to improve, reduce number of checks. All right. So for that, what you did, you set component change detection strategy to on push. All right. So you have done that. Now you are saying that there's two ways, that a pass new object from the parent component. Now the disadvantage of this approach is that even if you are passing a new object, that new object could be just the exact copy of the previous object, right? Let's say that someone who is working with app component has coded in such a way that for each key press they are creating a new object. See, you are the author of change, you are the author of count component. You do not have control on app component where this count component is used. We assumed that only on the save button it will create a new object and pass it to us. But it may happen that what if the user, the author of app component is written the component in such a way that even if user is pressing a key press, that component is creating a new object. And even if the new object is exact same copy of the previous object, if it is a new object, your change detector will run for the counter object. Right? Agree with that, everyone? So a new object is always not a guarantee of updated data. You agree with that?
Yes.
Only one yes? Other people, are you getting it?
Yes. Yes.
Yes.
So even if you are on the on push, and even if you are passing a new object, uh, you don't know the new object is actually carrying, you don't know whether new object is carrying new updated data or not, and your change detector will run. Then you thought, okay, let them pass, uh, not new object, whatever they want to pass, and I will make sure to run the change detector, and for that you have put a button. Again, if you put a button, then there are two challenges, that even if you have put a button, if the app component is passing new object, the change detector will run for the count component. And even if they're not passing new object, each time your button doesn't know that whether data is updated or not. So your user can keep clicking the button even though data is not updated, and it will cause change detector to run again. So we're getting the challenges here, even though we have moved to on push. Agree, everyone? There are challenges still. So still it will improve the performance a lot, but how we can improve further? And so to improve further, let's say that we are following something like this. Find data changed. And if data changed, then manually run the change detector. If I can do that, hey, find data is changed. So from count component, if I'm able to find whether data in app component is changed or not, and if I'm able to find that, then I'm changing the change detector manually, running the change detector manually. I should able to avoid above two problems. So what if I create a component? If I follow something like this for best performance application, create a component and set it to on push. Okay, then make sure that parent components does not pass new object. All right, in the create a child component. In the child component, find data is changed in the parent component first, and second, if data is changed, then run the manually. If I do this, we would improve performance even further. Agree, everyone? If we follow this algorithm.
Yes.
Yes.
So someone asked me just half an hour back if data changes, and I told you change detector is not able to understand whether data changes or not, but we can understand in our code. So if you go to in all of these, the major challenge is how to find data is changed in the parent component. Can someone answer me that? From yesterday class and day before yesterday class, how would I find data is changed in the parent component? How we can find data is changed, not in the parent component, anywhere in the Angular application, how you find that?
And
NG on init, yeah, but how would you find the data is changed? You remember Dhananjay Mahendra object? Dhananjay value had changed at 9 a.m. Mahendra value changed at 9:15 a.m. Consumer, source,
Observable.
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 observable, right? So right now, if I go and change, so right now this object is a normal object, right? Since it is a normal object, if data changes, it is not notifying to the consumers. But if I convert this normal object to a observable, it should able to notify, right? Whenever something changes in it. Agree, everyone?
Yes.
Yes.
Right? So let's do that, how we can achieve that. So what I'm going to do here in the parent component, let me comment this gentleman and say that, let's say that I have a count that value is 1. You are able to see my Visual Studio Code? Yeah. So count value is 1. And then here I'm saying counter as any. Okay. And then in ng on init, right here, I'm saying this dot counter is equal to new behavior subject, which is of type number. Okay. And in this number, we were passing a new object, and that new object is count is 0. Okay, because that's an object. So here we are saying this dot counter new behavior subject, and as I taught you, there are 4 ways observable can be created in RxJS: subject, behavior subject, relay subject, and async subject. So here I'm saying this dot counter new behavior subject any, and here we are passing an object count equal to 0. Then in increment count, what we would say this dot in the increment count, what we are doing, we are saying this dot counter dot next. So whenever user clicks on that button, it will emit a new value. We are saying this dot counter dot next, and in this we would say count is equal to plus this dot count. So it will just whatever is the value, it will first increment that and assign to that. All right. So here what I have done, I have created a variable called counter any. Then I'm creating that as a behavior subject, and then there is an object which is wrapped inside that behavior object. Then when user clicks on this button inc count, we are saying this dot counter dot next. So the next is a method which will emit new data. Remember, observable has data, error, and complete. So to emit new data, you call the function next, which I'm doing here, count this dot count. Okay, and then we can go to here app counter in here app counter is fine. Okay, next what we need to do in counter component.ts, now this is any. So whenever data changes, this ng on changes would be called, and you know that now the type is observable. It means to work with that, we need to subscribe to that. So what we'll do here, we'll say count is any, and then counter, and then in ng on changes, if we say this dot counter dot subscribe data, and then we can say this dot count is equal to data dot count Okay, so we are saying this dot counter subscribe data dot count. So this is your and then comma. If we have error, then we can say error console.log error. It is asking me to, and then we can say complete console.log complete, and then we can say here also error and any. Okay, and this is how R is. And I'm writing the best practice code for you. Okay, and here we can say count subscription dollar is any, and then here I can say this dot count subscription dollar is equal to this, and then here we can say on changes and then on destroy, and here let's say that ng on destroy is equal to this dot count subscription dollar dot subscribe. All right, so here we are doing this dot count equal to data dot count, and let's say that we are printing also console dot log this dot count, and this code you are already familiar with. I'm doing nothing. I'm just in app.component.ts. I have changed the type here to behavior subject. From the behavior subject, I am passing an object. When user clicks on that increment count, I'm saying that next. Okay, then app.component.html counter, and then in count.component.ts, we are saying we are just subscribing to that data, error, and console.log. Now, what we are trying to achieve here, if you go to the problem statement again, we have this data on the on push. This default is the strategy of this component is set to on push. And we are now trying to find out whenever the data which is passed in this component using input decorated property, we are reading that whether that data is changed or not. If that data is changed, okay, if that data is changed, input counter any, we are subscribing to that. So you see that we are subscribing to that, and then we are reading that. So here, if data changes, this particular line number 31 and 32 will be called. So once we have information that data is changed, then what we could do, then we could make sure to run change detector manually. All right. So in that case, the change detector would only run when data changes. And here I am. Let me go and share Visual Studio, share browser with you. But before that, we don't need this refresh child anymore. So I have deleted that. File save, and here I am. Share, okay. It is not binding, we would see that in a bit. But when I do update count, you see that I'm getting the updated data. So 2, 3, 4, 5, 6, 7, 8, 9, 10 means in the count component, I'm able to read the data which is changed in parent component. I'm not passing new object. That is why data is not being, the template is not being rendered and all those things. But at least we have done the first part. Now for the second part, what we'll do here for the second part, all right, so let's do one thing. We need to run the change detector manually. So to run the change detector manually, first in the counter, we'll say private cd and inject the change detector, which is change detector ref. Once you have injected it, that service, we know that here data is changed. So we'll say this dot cd dot. It has a lot of functionalities. Deattach means deattaching, reattach means again reattaching. Check no changes means don't run change detector. And there are two, detect changes and mark for check. Here, I'm doing detect changes. I'll tell you the difference in a while, what is difference between detect changes and mark for check. But both are used to run change detector manually. So here I'm saying that, hey, detect changes. And if I show you the screen again, okay, so let me go and check whether I'm displaying correct data or not. So here we are saying count this dot count equal to data dot any, count any, and here actually I need to display not counter dot count but just count, right? So here file save, and here you are updated count, and you are getting the updated count. So my friend, you have written a component which could be written in the best possible way. Now your child component is set to on push, and then you are reading the value of one of the input decorated property, that whether that value is changed or not, using the subscribe, and inside that you are manually calling the change detector. And when you are manually calling the change detector, you see that your change detector is running only for this component when you are your data is changed. And if I show you the code again, this is the code which we have written. So we have achieved almost there where we wanted to achieve, right? And this is what you should practice in all of your component, at least all of your child component, that run the change detector only when data changes. Now, how would you identify data changes? By calling the subscribe method and making sure that you are working with observable. So here, if I go and show you our problem statement, now do you think we have improved the component? And we know that when thousands of components, this approach would improve performance in a very good way. Everyone, I'm open for questions. You should have like at least 10 questions. I'm open for questions.
Can you open Visual Studio Code?
Yes.
So we did here manual change detection, right? So
Yeah,
do we need,
that is line number 32. Yes.
yeah, so do we really need that because changes are detected, right, by NG on changes? So I think that wrong name might be causing the issue that
Sorry.
we corrected that variable name, right? So I think that thing might work
I
alone.
don't know. I did not. What is your question? What you are trying to say? Say again. NG on
So
changes. Yes, we have NG on changes.
yeah, so on line number 32, we manually called cd.detect
So you
changes, right?
want me to come into this?
Yes,
Okay. And now should I go and run it? What you are say? What
yes.
what you are trying to say? Like what is your question?
So I just want to know if we really need to call this cd.detect changes or because of this, was it binding to the template or it will bind without it as well?
What you are learning since morning then?
Okay, understood.
I did not understand your question. You were saying that NG on changes. What was your question again? Say again. Did I answer that?
So I think he's the earlier it was a default chain detection policy, right? The strategy. Now it is on push. If
Yes.
you're changing to on push, that means it will not trigger. Earlier it was triggering because of the default, right? So
Oh, okay, okay. He thought it is set to default. So without even doing detect changes, it should run.
yeah,
That's what he thought. Okay,
yeah.
no, no, we have changed it to on push. So it would never run that. That's the whole learning of this session, right? That if it is changed to on push, then only, of course, if it is set to default, then even if it is commented, it will run. That you already know that, right? If it is set to on push, then either you have to pass new object. If you're not passing new object, then either you then do one of those three operations such that event or xhr or asynchronous javascript function. And we discussed about that what are the challenges in those two approaches. Even if we pass new object, that new object could be just the exact copy of the previous objects. Second, and the other disadvantage of new object is that if there are hundred of properties in input, hundred of input decorated properties, and if there's a new object for any of the property, change detector will run. Then we saw putting a refresh button. Then again, you saw that, I mean, that is not a good user experience first. And second, your user can keep clicking on that button. And even if data is not updated, change detector is running. Then we came up with a solution that we should follow as a best practice always for child components, that create a child component with on push. Then make sure that the parent components, means the smart component, does not pass new object. Always a smart component pass. This is the best practice you need to follow, and that's what I'm trying to tell you for last 2.5 hours. Only to reach this highlighted line, I have gone step by step and explaining you everything. Making sense? So whenever you write a child component, like there could be some scenario when this may also not work, but in most of the time, create a child component with on push. Okay, then make sure that parent components does not pass new object. Means you always pass a behavior, subject, and observable kind of thing. Then in the child component, find data is changed in the parent component. And how you are doing that? So you are doing that here up to this code, right? And then you know that, hey, data is changed, means I need to manually call the change detector, which you are doing that in line number 32. Is it clear, everyone?
Yes.
Now there are two ways you can manually call a change detector, either using detect changes method or using mark for check. And these two are very important. When to use what? In this scenario, mark for check will also work perfectly. Okay, so in this scenario, mark for check will also work. Right. Now, what is difference between mark for check and detect changes is very important. Now, mark for check says, if you use mark for check, it means you are telling Angular that, hey, it looks like something had changed on this component. So whenever next time you run change detector, please run change detector for this component also. And don't look at the configuration and all. Just run this whenever next time you run this change detector for this component also. So by doing that, we are just marking this component dirty, such that whenever change detector runs next time, it will run change detector for this component. And you know that change detector always runs for the parent component, and so on, so on, so on. So let us say that you have done mark for check at 10 a.m. 40 second, and change detector runs at 10 a.m. 41 second. For 1 second, you don't have the updated data in case of mark for check, because here you are not actually running the change detector manually. Here only you are requesting the Angular that whenever next you run the change detector, please make sure to run change detector for this component and all its child component. Is it clear, everyone? However, when you say that detect changes, it means you are telling Angular that, hey, stop everything just right now. At this moment, run change detector for this component and all its child component. So in detect changes, it will not go to the parent component. Run change detector for this component and all its child component immediately now. So that's the difference between detect changes and mark for check. You need to keep in mind. But when in doubt, use mark for check. I'm going to give you a demo of detect changes in a bit, but I wanted to bring the definition in front of you. Okay. So if you have any question on this, I'm happy to take that.
Can you run the application again? So it is first time it will not detect, right? In this case.
Mm-hmm.
Oh, it's detecting all the. So you said like it's marking as dirty, so it will detect next time.
Mm-hmm. So let's say, understand it right. Like let's say right now the value is 21. It is the change detector runs so fast in the background that you're not able to notice that, but theoretically you understand that. So let's say at this moment I'm saying update count, value has become 22. It is happening both together, so you are not able to see the difference. But let's say that the value has updated to 22 at 10:01 and the change detector ran at 10:02. For that 1 second, you don't have that updated data rendered here.
Okay.
But it runs so fast in the background, you are not able to understand. So mark for check is actually not running the change detector. We're just requesting Angular that whenever next time you run the change detector, please run for this component. Okay. Detect changes says that, hey, please run the change detector for this component and all its child component right now. Okay. I'll give you one demo of detect changes in a bit. If by definition that is not clear to you, in a bit I'll give you a demo.
Okay.
Okay, but this is clear. This requirement, this best practices on push and subscribe and how they fit together into the bigger narrative. Just give me a moment, everyone. Yes. So, any question on this team?
Sir, I have one. We are using that mark for check.
So now next time whenever there will be change detector, then it would be changing the value for that component too. But who will call that change detector now, because we have initialized it to on push. So there should be anyone else who will fire some change, and due to that change the mark for check component would also get changed.
Very good question. But understand this. I, no one calls change detector. Change detector is like those in on our street, those garbage collector comes, right? The people who comes to collect the garbage.
Yes.
So daily morning they would come whenever they have to come, right? They would keep coming. But if you call them, they will definitely come at that point of time. If you WhatsApp them, they will definitely come on that point of time. If you at that point of time to that home. So even if someone is not WhatsApping them or someone is not calling them, they would come. That's their daily job, right?
Okay, so you mean to say that
And
even
mark for check means someone has put a notice in beginning on the morning that hey, don't collect garbage from my home. So that garbage collector is saying, okay, fine. But suddenly this home has some garbage. So they put some garbage on the front and put a mark that, hey, please collect this garbage whenever next you come from, you visit from here. So that is mark for check. So no one runs change detector. Change detector, the first time you run Angular, change detector keeps running 1,000 times in a second. Only, so Angular framework runs change detector, you can think like that. Only you can run change detector if it means you, not Angular. You in your code wants to run change detector on certain things. So for example, right now we know if you see this code that hey, data is changed, and I don't want to wait. And like here the scenario is a little bit different due to on push, but you want to make sure that change detector should run at this point of time. Then manually you can run it. It doesn't mean that someone has to call the change detector. Change detector keeps running in the background. But if event happens, XHR happens, asynchronous method happens, or you are manually calling that using mark for check or detect changes, it will run that time also. Even if none of this happens, it doesn't mean change detector doesn't run. It keeps running. In only way, change detector will never run if you are so ambitious and so Angular hacker that you go to the root component of your application. And in the root component itself, you are saying this dot cd dot detach, which you should never do that. It means you have logged the gate of your column. Now garbage collector cannot come.
okay, got it.
Right?
So on keeping on push or so, still change detector will be running because we have not detached its
Running for the application, not for that
application. Yes.
component. Yeah, it would not
Okay.
running for that component only. And remember in beginning we talked each component has its own change detector.
Yes.
Yeah. You got your question answered, like you understood it, what you asked?
Yes. Yes. Yes.
Okay. Okay. Next question. Okay, should we move further? You are able to see my Visual Studio Code ng on changes, right?
Yes.
Yes.
Now you see that for one input property, we have like almost 10 lines of code, right? To achieve whatever we want to achieve. assume a scenario, and you have seen this exact kind of code while consuming API also, right? Like subscribing, then uh, mm, error, then complete. You have seen this code yesterday also. Now, here for one input decorated properties, we have like 10 lines of code. Assume if you have 10 input decorated properties, then you have 100 lines of code. And if you forget to do unsubscribe, then there could be memory leak and all those kind of things. So you see that this code is something I mean, it is working, but it is a lot of code. Can we minimize this code? Okay. So Angular knows that this code, what is in front of you, is very often you got to write. They know that you have to deal with observable. You need to get data from an observable, and you need to show that data on the template. Angular knows that. So to avoid all of these, what Angular has done, it has given us something which we can use as it is, and we do not have to write all this code. Okay, and let's see that what is that. So what I'm going to do, I'm going to copy this whole component, Control C and comment this. So you see right now, there were like 44 lines of code almost. If not 44, then almost almost 40 lines of code to achieve that, whatever we were achieving, right? I'm copying this, Control C, and I'm just pressing that in the bottom. The objective and the requirement, everything is same. We are trying to achieve exactly the same thing. Only we are going to write minimum code using something Angular provide to us. And then I'll explain you how we can do that. Okay. So here, I'll go here and say, I have one input counter any, and then I delete this count. I'll delete this counter subscription. Okay. And then I will even delete this private CD change detector ref. Then whatever code I have written here, I'll delete that all. Then of course, I'll delete this. So my code has only that input counter where data is being passed. So I deleted everything. Here in template, we need to print that. So in template, what I would say, I'll modify this template a little bit. I'll say div and here I'll say display this div in G if equal to display this if there is some data, right? If there's something in the counter. So we'll say that take this counter and that counter has let data. We're taking that in the data thing. And here we are saying the div. And here we are saying count in child is data.count, right? It should work div. So what I have done, this let data is just to read the property out of that counter. You can easily find that in the ng if in ng4. But you see that here my ng on like my counter component has nothing, just a value declared, right? Now to earlier what I was doing, what was the task I was doing? Whenever data was changing, understand it. Earlier what I was doing, whenever data was changing, I was subscribing to that data. Then I was manually running the change detector, and then I was unsubscribing to that data. So these three steps I was doing whenever data was changing. Agree? We are doing that here in line number 25 to line number 39. Whenever data changes, we are subscribing, we are manually running the change detector, and then we are unsubscribing. So these three tasks we have to do for every data changes, right? And it was working fine. Everyone agree with that?
Yes.
Yes.
Now what I'm going to do here, I have removed all of those code. I have just this input counter any, print any declared there. And here I'm saying that display this data count in child data.count in div. And here I would go and use a pipe. All of you are aware about a pipe? All of you know there is a pipe. I mean, you can create pipe, and there are currency pipe, uppercase pipe, lowercase pipe. There are many pipe
Yes.
provided to us by Angular. In the same way,
Yes.
Yes.
Angular has provided us a pipe called async pipe, ASYNC. So when you do that pipe, when you do that async pipe, just a minute. Uh, so here I'm getting error data.count. All right. So I'm fixing it, but before that, you understand what is the purpose of async pipe, and it should always use async pipe. Now, what async pipe does, okay, that is something here, question mark and all, I'll fix it. What async pipe does, if you use async pipe, it does those three tasks for you. So async pipe, if you are working with an observable, and counter is an observable here, right? So what async pipe does, whenever what async pipe does, that whenever, okay, I did one mistake. Instead of this, I'll say observable any, and here it is saying no. So I can say this dot counter equal to new observable. Okay, so what it does, what async pipe does, it does those three tasks for you. Whenever data changes, what async pipe will do, it will subscribe to that data, it will run change detector manually for you, and it will unsubscribe to that observable. So whenever you are working with observable in your application, yesterday I saw you that you did dot subscribe and then data, then error, then complete, and all those kind of things. Instead of that, you can just use async pipe. And then internally, Angular will take care of unsubscribing. It will take care of making sure that whenever data changes, updating the template and everything. So this is what async pipe for you. Let me see whether I'm getting the output. So here I am there. I'll say update count. You see that I'm getting the output here. So what async pipe does, once again, it does all tasks for you. So here your code is just one, two, or like you have reduced the code, number of line of code, and if you have 100 of input declared properties, just declare that properties, and wherever you are using that, use async pipe. The advantage of async pipe is much more than less number of code. First is that if you can work with async pipe only with the observable. So whenever data changes in observable, it will run the subscribe internally. And then it will make sure that data is in sync with the template, means run the change detector internally. And it will make sure that that observable has been unsubscribed. The one advantage of using async is that in my component, if I'm changing it to default, let's say that I'm working with on push, then I'm changing it to default. Since async runs change detector manually each time, even if I'm changing from here to there, I don't have to change any code. Here, if I do this, change it to default, and if I have this code, then I got to uncomment it. Otherwise, change detector will be run twice. Or if I change from default to on push, then I have to come and put this code again back. So this is the purpose of async pipe. You should always use async pipe whenever possible. There could be scenario where you need to use subscribe, means let us say that you want to run some business logic, that if updated data is this, then do that kind of thing. In that case, you need to write some code in line number 28 to 30. However, then in that case, you need subscribe. However, most of the case, async pipe will work for you. So everyone clear with the async pipe? you'd come across async pipe a lot in all popular, all official Angular documentation. Once again, what async pipe does. So if you use async pipe, it works with observable. It subscribes to data change. If data changes, it runs change detector manually. And fourth, when component is destroyed, it unsubscribes. So it does all those 4 tasks for you. Otherwise, you got to write those tasks yourself as you did. Both code are there for you for your reference. Any question on async pipe? Any question on async pipe? Anyone? Should I move further?
Yes.
Okay.
Yes.
So if async pipe is clear to you, now you may say that, hey, this is good so far. Can I make it even performance better? This is the best you can achieve. But still, if you want to be very experimental, what you can do, you can attach and detach, retouch and detach the change detector. So you can go to a component, you can say that, hey, attach the, you can go and say that, hey, on the constructor of that component, you can detach the constructor, and then you can again attach it on certain business use case. Okay, so let's say that, let me go here, and in this component, in the constructor of the component, we'll say private cd what I'm going to do, I'm going to comment this also such that you have a sync pipe implementation. Okay, and commenting this also such that you have this, and then I'll just copy paste and create a component again. Okay, and here attaching the component there. All right, so here I am. So let's say that here I'm saying private cd change detector ref. And as soon as you are in the constructor, you are saying, okay, this dot cd dot detach. Now you have detached the constructor, and let's see that how it works. So if you go here, since you have detached a constructor, nothing would be rendered, right? Like those, your interpolation is not working. You are not, you don't have anything rendered here. If you do the update count, also nothing is happening because for this particular component you have detached, there's nothing happening in that, right? We are not printing the data also and all that. Now, many people follow this approach, and we call this detach pattern, detaching pattern or something. So you have detached the component, the change detector for that component, and of course for all the child components further. Now what may happen is on certain business scenario, you want to reattach. You say that, hey, I'll reattach this on certain business scenario, or run the change detector, and then again reattach. Again, I would not recommend this you to do that, but just I wanted to show you, so I'm showing this to you. Okay, so what I'm going to do, I'm going to put a button here. And let's say that we are going to modify it. Let me make it first. Oh, this should be on the on push. It doesn't need to be on the default, okay? So don't get confused. Async pipe works with on push also. So that's why I'm changing here. Here, I'm going to show you that I have made it to default, and let me make it a little bit easier to work with. So what I'm going to do here, I'll get rid of this. I'm putting title count in child counter or child. Okay, then that is set to default. Then here I'm saying get rid of this, and here I'm saying input detached component, and then that is a counter, and type of that is any. Hello, am I?
We cannot see your Visual Studio Code.
Oh, is it clear now?
Yes.
Okay, what I was saying that here for app for that async pipe works on push. So that's what I changed there in the command, because while explaining I changed that to default. Remember that? Okay. Now what I'm going to do, we are learning that how we can work with change detector detach pattern, where for the component I'm just deattaching. Again, I don't recommend this, but if you have to do that, how you can do that? Okay. So here I'm saying change detection strategy to default, then count in child counter.count. And then I have a button here called attached, which is refresh. And in that button, what I'm going to do, I'm saying this.cd.reattach. Okay. And let us go ahead and in the app component.ts, so far we are right now we are passing that thing. So here, instead of this counter one, let me take and say something called counter one equal to any, which was earlier. And here I can say, sorry, I'll call counter one. And here I'll say this dot counter one dot count. So that's what we are doing only there. File save, we are here. And we need to display the data. So update count and reference. Okay, so here I am, right? Let's go here in app.component.ts. And here let's print that this.counter.count. Okay. Now the count component which I have created, please understand that it is set to on default, set to default strategy. However, as soon as this is created, I'm deattaching that. Okay, so I'm deattaching that, and I'm saying file to save, and then I'm sharing the output with you. And here you see that I'm updating the count. Oh, it's undefined anyway, so we need to make that to 0 somewhere in the app.component.ts. This dot counter dot one. Okay, file and save. And right now you're here. So you see my browser, I'm saying update count. What? Okay, now it should be fine here. You can see my Visual Studio, see my browser. You see that here I'm saying update count. You are getting the updated data. However, nothing is happening in the child component because that the component is the change detector of that component is deattached. There is no change detector for that. When I click on that refresh button, I'm reattaching that, right? So I'm saying refresh. Now the change detector is attached and everything is there. Now when I click on update count, it should display me data. Let me go and check why it is not displaying that. So here, it is counter, any, detach, and reattach. Yeah, it is attached, reattached. Then it should change its strategy. Counter dot count. Are we sending from there counter dot count? It is counter dot count. Oh, okay. Here we need to pass counter one. All right. So now here, once again, if you go to the output, refresh it, and here you say that update count. You are getting the updated count. It is not reflecting because change detector is not attached. You say refresh. You are getting here. Now you are getting update count 14. So this is the way many people do that. But the problem with this approach is that you have to be very careful with the change detector because you are breaking the whole tree. Second is that you are using reattachment. So after that, it is reattached and the change detector is running. The other thing what you can do is instead of doing the reattach thing, because then change detector is running each time, you can go here and say that hey, just run once, don't deattach it. So here, let me go to the counter.component.ts, and let's say that here I'm saying I have deattached it. I'm not doing reattach. I'm doing this dot cd dot mark for check. Okay, so I'm saying this dot cd dot mark for check, and then again, if I can show you the browser, right? And here, update count, it is getting updated. Refresh. Nothing is happening for you. You know why? Because mark for check only works when your component has the change detector. It means it only works when you are already paying monthly bill to the garbage collector and then saying that, hey, please collect the garbage again whenever next time you come. But by doing detach, what you have done, you have unsubscribed to the membership of the garbage collector, which comes to your lane. Now, even if you put that, hey, there's a garbage please collect, that person would not collect the garbage because now that person is not subscribed to collect the garbage from you. So in count component, what I have done, I have deattached the change detector. So if I have deattached the change detector, and then if I say I have mark for check, that component is not part of the change detector tree. So even if next time change detector is running, it is not going and running change detector for that particular component. Am I making sense? So to avoid that, so to make sure that you run that, you have two options. You can go and do this.cd.reattach, but if you reattach, then it is reattached, and then each time change detector runs, it would run. However, if you do this.cd.detect changes, it will definitely run once. So it will run once, even if your change detector is deattached. So it will run once for this child and all its child component. So here, let's go and see the browser. So update count, you see 7. Now you're updating count, nothing is happening because it just attached once, ran once, and gone. Then the phrase, then you get that. So now you got a purpose of detect changes also. That detect changes runs even if that change detector is deattached from the component tree. Right. Guys, I have one emergency. Can I take a break of 5 minutes, please? Hello.
Yeah, sure.
Yeah, so I'll be back at 12 o'clock. We'll start. In meantime, I'm opening this Visual Studio Code for you. If you have any question, you can note it down. Okay? 12 o'clock we'll start. Yes, guys, I'm back. So if you have any question on this, please go ahead. Should we move further?
Yes.
Okay. Now let me note down some best practices for you when you write an Angular application. Okay. First, whenever possible, do lazy load of modules. Okay. Second, always use providing options such that your services are recyclable. Third, always use pipes. So let's say there's a requirement to achieve, and if you just go and read in Angular documentation that whether there's a pipe available for that or not. Don't try to write your own function. So always, if you have to do something, create pipe, not a function. Fourth, for child components inside the module, inside the route, make sure to put a strategy to on push. 5, make sure to use async pipe. If not using async pipe, because there could be some requirement where you cannot use async pipe, make sure to unsubscribe to the observable. If not using async pipe, make sure to unsubscribe to the observable. That is, so whenever possible, do lazy load of modules. Always use providing options. Always use pipes. For child components, make sure to put a strategy to on push. Make sure to use async pipe. If not using async pipe, make sure to unsubscribe from the observable. 7 is that always make API call in the service, not in the component. 8, always write DOM manipulation in the directives, not in the component. You remember I taught you to create custom attribute directives. So let's say that if you have to set header, you have to set background and all those kind thing, don't read the element using view child and put that in component. No, always write DOM manipulation in the directives. For that you have directives. Never create until you have very, very strong reason custom directive. Okay. Use combination of subjects and observable inside a service to share data between components. Use local storage and observable to maintain state. Be very careful and do lot of discussion before using libraries such as NGRX. Just don't jump using that. The whole learning curve is different. Just make sure, since someone is saying NGRX for state management, the first Google search result gave you that, don't start putting NGRX in your project. I have consulted more than 15 customers so far in last 2 years. Very big application, we never need NGRX. So do very careful discussion about that, because for your new people, the whole learning curve would change. So always the combination of on-push, observable, local storage, service should able to help you. Doesn't matter how big is your state management there at the client side. What is a state? A state is that there's a data, whatever the value changes in that data, whoever is using that data should get updated for that, right? You know, observable is for that. So these are the small things keep in mind. And if you do that, you should be fine from the very, very first day. There are some advanced suggestions also, which I'm not putting it here, but those are things also you can do. For example, create a module and load a modules and dynamically and all those kind of things. But anyway, so everyone now, do you understand this? Whenever possible to do lazy loader models, the whole class, would you be able to, do you know that what is that, right? Whenever possible, do lazy loader models. Like how to do lazy loader models, you understand that, right? So if let us say Mahendra is coming to you and saying that, hey, create a lazy loaded models, you would be able to do that. Yes or no? 25 people.
Yes.
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 If Mahendra is coming and saying that, hey,
Yes.
always use providing options, you know that what does it mean, right?
Yes.
Yeah.
Then it says that use pipes, you know what does it mean? For
Yes.
shell components, make sure to put a strategy to on push, you know that. And also one thing here that if I put it in the bottom, identify a smart and dumb component. Identify smart and dumb component, right? Don't make API call on each components. This you have to do. So before writing a subsection, sit together in your team and identify, okay, this is going to be the smart component, this is going to be the dumb component, and all those things. See, keep in mind, even we know that we do screen-driven development, right? We go screen by screen, screen by screen, but one screen could have multiple components, right? And you need to identify what is the smart component and what is the dumb component. I hope all of you understand what is smart component and what is dumb component, right?
Yes.
Yes.
Okay. All right. So these are the some points, my suggestion for you to write best practice, to follow best practices. If you have any question on any of these points, please ask. If you have any question in change detection, please ask. If you have any question from previous classes, please ask. And then I'm jumping to the testing. Testing is very, I mean, only you need to know the syntax. That's it. So I'll just walk you through the syntax. But if you have any question in these points, please, I'm happy to discuss that. So in team meeting, interns, now if your manager, your architect is using these words that, hey, use observable to share data between the components. I hope now you understand what does it mean exactly, right? Interns?
Yes.
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 Good. All right then. So if you have any question, ask. Otherwise, we would go to the testing part. Should we move further? Should we move further, T?
Yes. Yes.
Yes.
Okay, good. So here for test, I'm not going to write code, We already have a lot of information, but I have already written the code and I'm just going to walk you through that. So in Angular application is already configured to do the unit testing. Now, what is unit testing? For the interns, if you do not understand what is unit testing. Now, unit testing is a combination. So you write unit test of the functionalities. So let us say if I'm asking you to create a calculator class or calculator. Now, in calculator, you are going to have 4 functions. In the calculator, you are going to have add, subtract, multiplication, and division function. And you have written code in that for the add, for the subtract, for the division. You have written that code. That is fine. Now, if you have written that code for add, subtract, division, and all, now as a developer, you have written that. Now, how you are going to identify, how you are going to verify the code which you have written is correct code or not. So let's say that if you pass 2 number to an add function, that function should return addition of 2 positive numbers. If you pass 1 positive and 1 negative number to the add function, that should return you subtraction of those 2 numbers. You got to verify those things after writing that function, writing that add function. Now, this different input to that function is called test data. So like first you pass 2 positive data, second you pass 1 positive, 1 negative data. You may pass 2 negative data if that function is expecting 2 parameters. Here I'm assuming that. Now, how you are going to verify these things? One is that you go and create a screen, use this function, and then in that screen you enter that and you do that testing. That is very much possible, and we do that, but that is called manual testing, and it's or UI testing. And in that testing, the challenge is that you have to create you as a developer, you have to wait until that UI is ready to test your functionality. Most of the time, the UI is done by some other team, and as a developer, you are doing only the functionality part. So you got to wait, and that is the challenge. So what unit testing says, and that is called UI testing or UI testing mainly, or the manual testing, and that can be done using automated and manual both ways. Now, what unit testing says? Unit testing says that, hey, whoever is implementing that functionality will write another code to test that unit of functionality. So whoever is implementing will write another code to test that whether that code is implemented correctly or not. So there wouldn't be any screen, there wouldn't be any UI. It would be completely a code testing another code. So you have written an add functionality, then to test that you write another function. And if you do so, that is called unit test. So always the developer who implements a functionality should write the unit test for that functionality. Now, unit test could have multiple test cases. Like if you take that add functionality, there would be a unit test called it should add 2 positive numbers. There should be a unit test called add function should subtract 1 positive and 1 negative number. Then add function should add 2 negative numbers, something like that, different set of data, and you can pass that. So this is called unit test, and unit test is always written by the developer who is implementing that functionality. Now, keeping that in mind, Angular assumes that developers who are going to work on that are going to write the unit test. So when you use Angular CLI, by default, your project is configured for unit test. You do not have to do anything to configure. So what Angular does, there are many, in different languages, there are different unit test frameworks and unit test libraries. In JavaScript world, the most popular is Karma and Jasmine. Now, what is Karma? What is Jasmine? Karma is the test engine, unit test engine. So Karma is a program which runs your unit test. And Jasmine is the library which provides you the syntax. So you write in Angular unit test using Jasmine, and you run the unit test on the Karma. And those are already configured by default. Having said that, if you have a requirement to run your unit test on some different test framework, you can do that. You got to configure it. If you don't want to use Jasmine, you want to use something else for the syntax, you can use that. But you got to configure that. But I don't see you would have any reason to do that. So whatever is the default, you can use to write unit test. Now, when your Angular application is let's say that configured. So when you created an Angular application, as soon as you create an Angular application, that Angular app using the Angular CLI that is configured to run unit test, and you can run the unit test using the command ng test. So when I run that, whatever unit test is there in my application, it would go and run that. Now, every component has a spec.ts file. Every pipe has a spec.ts file. Service has the spec.ts file. Directive has the spec.ts file. So you write that you write unit test for that component or for that pipe or for that directive inside the corresponding directive.ts file. So here, if you look at here, it tells us that there are 5 test cases I ran. Out of that, 3 success and 2 failed. And if you look at the browser, so just a minute. Okay, so if you look at the browser here, you see in the browser also it gives you that Karma is connected, and that has 5 specifications so far in my application. 2 were failure. So if I go to spec list, it tells me that I have written a test for pipe. In that should convert byte to megabyte is failed. Filter pipe, those 2 are passed, and it says that stock counter component should increment correctly, it's failed, should create is passed. If I go to should convert bytes to megabyte and click on that, it will tell me the exact reason that why it is failed. It tells me that it is expecting 0, but so that has 2 tests failed, where the first test is a stock counter component where expected result is 0, and that is and the result which we are testing is 1. So it is failed, and then it is saying that for the pipe test, expected is this, but it contains this, and that's why it is failed. So this is the way you can go and find out in the browser those tests. So here, let me go and show you that how I have written that test for you. So in Visual Studio Code, what I have done, I've created a pipe called filter pipe. A very simple pipe. Can you see the Visual Studio Code for me?
Yes.
Yes.
So this is a pipe we created. You know how to create a pipe. That pipe takes a size and extension, and whatever we pass, it just tells us that what is the MB. So we'll pass. If we will pass whatever number we'll pass, it will divide that by 1024 and 1024 and tells us in the MB that what is the value of that. So that's the filter pipe. Now, how you are going to test it, whether this functionality which you implemented is correct or not. Of course, you can go and use that on a component, and then you can pass that value, and then on the component you can verify that okay, this is correct or not. But again, you have to wait for the component to be ready and all those things. However, here we can go and write unit test and verify whether this functionality which we implemented is correct or not. So this pipe is clear to you, everyone? Pretty simple pipe. Now let me go to, so for that, the test I have written in filter.pipe.spec.ts. So if you go to filter.pipe.spec.ts, the first thing is what we are doing here. We are importing whatever is required. So here we are importing various things. Let it be. Now, the first thing is that you need to set the test environment. And here I'm saying test bed. So in Jasmine, there is something called test bed that is used for the whole test. And then it has a function called init test environment. So I'm calling that function test bed.init test environment. And then I'm saying that here import the browser testing module. browser dynamic testing module and platform browser and call platform browser dynamic testing. So this is what you need to do to test in a browser. So that is the setting of the test environment. Either you can do it for each component or pipe basis, or you can go to test.ts, and in the test.ts you can do it for the whole application also. So if you do it here, you can do it for the whole application together, or you can do it for the particular component or pipe or particular item level. So this is clear. Once the test is environment is set, there's a syntax called describe. Describe is to use to create a test case, right? So here we are saying, and the test case could have further test case. So here I'm saying describe pipe testing, and that takes an arrow function, a callback function. You can give any name, and inside that I'm going to write two tests. One is called filter pipe test. You can give any name here. You can go and say filter pipe test, whatever name you want to give. Okay. And now what I'm going, so writing unit test for pipe is the simplest. First, I'm creating object of filter pipe. You remember that we created that filter pipe. And once we have created that object, then we are writing a test. We are saying create an instance, whether this is successfully created or not. So expect pipe to be truthy. If there's some problem in creating this test would fail because it wouldn't be a truthy value. So this is the one test we have written in one test scenario here in the filter pipe test. This is one unit test. Once that is created, we are saying it should convert bytes to megabytes. And then we are expecting and then calling pipe.transform. The pipe has a transform function and we are passing some value here and we are expecting this to come. Then again, we are passing some value and we are expecting this to come from that transform function. So this is your actual value. This is your expected value. This is your actual value, what you are passing as the input parameter to that. That's it. So writing test for a pipe is pretty simple. Just create an object and do that. All right. So when you do this is called shallow pipe testing. What does it mean? That I'm just testing the functionality which I have implemented. But what if this pipe is used on a component, how it would behave? That is not tested here. Most of the time, this should do your job. You should not write test when it is used in a component, because if it is passed here, it means wherever we will use it should be used. It should behave correctly there. However, if your manager insists that, hey, no, write a test for a pipe in the context of component, you are saying that silo file size pipe testing. So here, what I'm going to do, I first need to create a component, right? Because I need to create a component and find out whether that template, in the template, that pipe is applied successfully or not. So here I created a class called test component that has two properties, suffix and size. Then I'm putting a decorator component and that has a template. And then in size, we are applying that filter which we created and passing the suffix. So this is my component, all right? And then declare some variable. Then I'm saying before each test, what you do, go and configure the testing module. And then in that we are passing, to work with a pipe in a component, you need to declare that. So here we are declaring that test component, we are declaring that filter pipe. So that before running this test, this should, like how you do in Angular application. If you don't declare it, you get that error, right? Because Angular doesn't know about that. So I'm saying declaring filter pipe and test component. And then here we are creating that component dynamically. We are saying test made, create component, test component. Once the component is created, then we are getting the instance of the component, and then we are getting the native element, whatever is displayed there on the component. So in the before each, we created a component, we declared a component, and then we are reading the element which is rendered on the component in the template. Then writing a unit test should convert bytes to megabytes. See here, detect changes, because right now the unit test is not into the Angular application. It means it will not able to detect changes. So I'm calling that detect changes manually. And they're just expecting that whether the text content of this element contains this data or not, 217.74 MB. If it contains, means that test is correct, otherwise it is not correct. So this is the way you can write unit test for a pipe. So here our pipe test is failing because we are saying it is 1, 2, 3. So it should be actually 117, I suppose, not 227. And again, you save it, you go to the browser, you go to the command prompt, and here it says that it executed 5 out of that 4 passed. Earlier it was 3 passed, but we fixed that. 1 failed, 4 success. So this is the way you write unit test for a pipe. If you have any question for the unit test of the pipe, happy to answer that. I told you there's no concept, just you need to know the syntaxes. Any question?
There are two methods you are saying. There are two methods to test this, to write down the unit test case for pipe.
Two method. Which two method?
You once is like you taken this component, test component, right?
Yeah, line number 51. Line number 51. Yes.
No, go up. So here you declare the component, template, size, and filter. You
Yes, I'm
component.
creating a component. Yeah, because when I'm writing unit test for this filter, I don't know whether the real component is created or not.
Okay, so this test component is nothing but your real component.
No, it's not a real component. It's just a component for this test.
Okay, I'm just trying to understand the purpose of this. Why?
Yeah, so understand, like, let us say I am the one who is assigned to create that pipe. So I created this pipe.
Okay.
Now I need to test whether I have implemented it correctly or not. Now assume a scenario that I don't have the real component created for me, that someone else is creating on the component, something called file component, which is the real component of the application. Now I'm going and writing the test. So here, one is that I done the normal test where I'm just calling the function and verifying whether that function is returning the expected output or not, which is line number 24 and 25. Is it clear?
Correct.
Now let's assume but I'm using that pipe as just a function, not as an angular pipe. So to use how a normal function becomes a pipe when you use that with this syntax.
Yes.
Right. So for that I need a component. I can apply that syntax only on a component.
Correct.
I don't have a component. Like I cannot use the real component. That's the whole purpose of unit test. So to test this, only I created a dummy component here.
Okay.
And in that dummy component, I'm checking. So of course, your real component would be much bigger than this, right? Where this filter pipe would be used. And here, then this is my component, I created it. Then I'm loading that because this is just a class. And this filter.pipe.spec.ts is not run by Angular framework. It is run by the Jasmine and Karma thing, right? So they are using these syntaxes. I am dynamically create that component myself.
Correct. Okay.
And then we are reading that native element, whatever is rendered in the template. And then I'm saying that if, and here you see that in the component I'm applying that, it means that native element should contain this value, the text of that native element. If it contains, it means I'm able to apply that to a component. That's how we are testing it. Okay.
Okay, so when you run this test case, you will get the UI as well, you are saying?
No, I'll not get the UI. I'm not rendering it. I've just created a class.
So how do you pass? So value is still the fixed value, right? The size is still the fixed, right?
That's how you do unit tests, right?
Okay. Okay, so still the values are fixed. I mean, yeah.
Yeah. So how you write it? Let us say you are writing a unit test for add. So you know that if I pass 2, it will return me 4.
No, that I
That's how.
understand. That I understand, Dhananjay. I was trying to understand, okay, is it something like we are making it more dynamic where the user can add the value and check runtime? But it's still
Oh, so
like,
you want to pass the test data at the runtime?
yeah, so I'm just trying to understand the difference between first and second, the approach, right? The
Okay.
one.
Let's see. The first
So here is also we are
actually,
passing the fixed value,
yeah.
right? And the below also we are passing the fixed value.
Yeah.
The
So I'll
only
tell you the
difference
difference.
is like we are loading the component and reading the fixed value from that component at runtime and running the test case, correct?
No. That is not the only difference. Here, it is just verifying whether that transform function is returning output or not.
Correct.
Okay. Here, we are verifying that whether that transform function, which is now being used as a pipe right here,
Mm-hmm.
is modifying the output template or not. And that's why we are taking the native element, because what a pipe does, it transforms the output
Okay. So you're testing the output of the component, right? By using the two
of the
content
template
of
that.
the template by using the
Yeah,
two content. Okay.
two continuous adjustment by doing this native element. So I have this in EL.
Mm-hmm.
The element is in the EL, and then I'm reading the text content of that. And here, then I'm applying whether that text content contains this or not. So
Correct.
here in the first case, I'm doing the just whether the transform function returns something to me or not. And here, when I apply that as a pipe, then that template should change. Like if you apply the uppercase pipe, then that should change to uppercase, right? That
Okay.
the
Yeah, got it.
so that's what we are trying to do it here. Any question? Should we move further? So always unit test is matter of your own discussion with the project, like what kind of test you want to do in unit test. And then, but all these syntaxes should able to help you to achieve whatever scenario you want to test. All right. Always need to keep in mind that you have something called test bed dot configuration test module, where you declare the filter pipe test component. Then you can use test bed dot create component to create a component. Uh, and then you can read the template using native element. Then that native element, if you do here console.log el, you'll find there are a lot of things in that. You can read a particular item in that, do the to contain and all those things. So any question on the pipe testing? No, good to go?
Yes.
Yes.
Okay. Next, let's see that how you can write the component testing. So here I have a stroke counter component, which has just a value and then there's an increment. And we need to test this component. Again, how to test the template, you have already seen that in the pipes, do native element and all. But let's do that how we can test this increment. So if you go to a stock component here, first we are again describing a stock counter component, component fixture, and then before each, we are here declaring a stock counter component. So we are creating that stock counter component. And then what we are doing here, that we are creating that component instance, setting the value, and then detecting the change. So here we can set the value to whatever we wish to set. Whatever we wish to set, we can detect that right here, right? So test bed.create component, stock counter component, you have already done that in the pipe. Then component fixture equal to component instance, then component dot value, whatever. So keep in mind the value is right here. We are setting that value. You can set all the values you wish to set. and then you are detect changes. You got to do that, otherwise Angular would not able to detect the change which you have applied to this value property. Then it should able to create the component. So it should create expect component to be truthy. Then should increment correctly. Component dot increment. You have the increment function there. Right now it will throw me error because there's no code in it, right? So what I'm saying that it should increment it, and the initial value is 0, so it should increment it to the 1. That's it. And let's say that if we save it and run this again, it is telling me 1 failed, 4 success. And here it is saying that a stock counter component should increment failed because expecting 0 to be 1. Let us go and fix it. So let's go back to component again. And here we can say, let's go and implement that. So go to stock counter.component and uncomment this. This dot this value dot 1. Now, when we back to this, and let's run the test again. And I guess that test should pass now. If you have any question, I'm happy to take that. See, all the tests passed now. 5 specs all passed, no test failed. And what I have done here, in the code,
You are not sharing screen.
yeah. Okay. So in the code, what I have done here is that, again, I'll walk you through this. We can comment this gentleman. Okay. So again, we are describing this. We are saying before each test create component, you did exactly the same for the 5. The component instance, setting the value, detect changes, and then you can just call the function and do that. If you want to check the template, something which you should not do that, but if you have to, you already know how to do that. For that, you have to do let el HTML element, and then you can read that el equal to picture.native element. Okay, and it will return you all the elements, and then you can check the test content and everything of that. So this is the way you write unit test for component. And okay, so earlier when we planned this session, we thought all of you would be writing the test in front of me, but it's okay. We have covered other topics in detail instead of that, and this source code would be available to you to write by evening today. Write those unit tests. If you have any query, you can reach out to me anytime. Before I move ahead, I walk you through the, because that is very important. I'll walk you through with something, and when you see my screen, just let me know. So you're able to see the browser, sorry, PPT, right?
Yes.
So today we got a change detection. If you don't know about me, completed 32 hours with me. My name is Dhananjay Kumar. I am a trainer and consultant. I have authored the book Angular Essential, which is no book in India on Amazon.in has on Angular has sold them this book. You already have this ebook available to you, which you got on the first day. I'm a Microsoft MVP. This slide is older, so now 11 times. I'm a Google developer expert in Angular and web technologies. I'm organizer of NG India, which is one of the largest Angular conference in the world, precisely the 3rd or 4th largest. uh, we call that conference as in NG India. Now you have like 30, 40 people working on Angular. So I'm sure you people will also join it when next time it happens. So in NG India, we get speakers from all across the world and attendees from all India, Bangladesh, Sri Lanka, Nepal, like around 1,000 attendees and all that. This is my email address. If you want, note it down. You can reach out to me anytime for any question. And this is my Twitter. If you're on the Twitter, you can follow me, debug_mode. Today we talked about change detector. So change, I'm just walking through that because that is very important concept. So the change detector detects the component for the data change and re-render the view to project the updated data. I'm sure all of you understand that. Every component has its own change detector. Angular runs change detector when an event such as click submit gets fired. XHR call to work with an API. A synchronous JavaScript function such as set timeout or set interval gets executed. You know that Angular component tree is like this. If you click in the bottom, it will start from the top and so on. So our whole purpose is to reduce that number of checks. These are the performance design consideration. Because it is directed graph from top to bottom. So it is good in the performance. So how to reduce number of checks? For that in change detection, there are two change detection strategies, default and on push. Default data changes to the input decorated properties. When you pass any data in the input decorated properties, if it is on the on push, then if you pass new object, then only it would change. Then you can deattach also, which I shown you, that you just deattach the whole component subtree and reattach it. That is the other way to do that. And then you can reattach that, or you can detect change. So you already saw reattach it back, detect change, just run a change detector for that component or the further component. It does not reattach again. So this is clear to you. You saw that in the demo, right? What mark for check does, if it is here, when next time it will make all the whole route dirty, and next time when change detector runs, mark for check, mark parent component up to the root component as dirty to be checked, and next time it will check the whole thing. So detect changes, run change detector for the component and its children. It runs cd once also for the component which is deattached from the component tree. Mark for check, it marks component with all parent up to the root as dirty. In next cycle, Angular runs cd for mark components. Reattach the component in the change detection tree. If parent's component cd is deattached, it won't help. So make sure to run mark for check with reattach. Deattach the component from the change detection tree. Binding will also not work for the component to deattach change detector. And check no changes, changes the component and its children and throws error if change detection runs. So if you do check no changes, you cannot run change detector. So what is change detection? You have data model, you have template. So here you have 2 hammer and 100. You know, that is the one it changes. Anyway, so you have already seen that. Then also you saw the async pipe. So async pipe for on-push change detection strategy, it marks component for check when data changes, unsubscribes from the observation for component destruction, and cleaner and more readable code. So all those three, what you do in subscribe can be done by async pipe. So use async pipe. Okay, so this slide, if you want, I can give it to you. Once again, if I show you the notepad, here is a notepad. We talked about whenever possible, do lazy load of modules. Always use providing options. Always use pipes. Child components, make sure to put a strategy to on push. Make sure to use async pipe. Async pipe, make sure to unsubscribe. If you're not using async pipe, make sure to unsubscribe to the observable. Always make API call in the service. Always write DOM manipulation in the directives. Never create until you have very strong reason to custom structure directive. Use combination of subjects and observable inside a service to share data between components. Use local storage and observable to maintain state. Be very careful and do not do a lot of discussion before using libraries such as NGRX. Identify smart and dumb component. So these are the best practices you need to keep in mind. And if I go ahead and show you the browser, once again, if you go to github.com and repositories, here whatever I have talked to you should be available to you for that. All those things you can go and cross check. There is one thing you can go and cross check. Okay. uh, and it already has service in lazy loaded module. So if you want to work, whatever I covered, its code is there, but that is already shared with you. All the dependency injection code is here. Node.js with type script is there. Then 2A data binding is there, and master detail is there. I'm contributor to the whole Angular framework as well. That's why it is mentioned here. That WebSocket which we are talking about, how to create that WebSocket in Node.js. So you have to first run this and then that, and then it has Angular unit testing also. So whatever I have covered is right here, and it has test for other. It's just a matter of syntax. It has test for file size, services, and everything. You can find it here. So I'll share this with you on the repository. Also, if you are on YouTube, feel free to go to channel Geek97, subscribe to this, and here you can pass. This is my channel, and here you can pass. You can find a lot of videos which can to help you to get along. So, for example, on Angular, there are many videos. There are videos on JavaScript, and all that. So feel free to subscribe to YouTube C Geek97. Okay, and all these repositories are also available. Now here we have done all the component, child component, directives, ng4, ngf. Component communication we have done, dependency injection services, reactive forms, template driven forms, working with API and routing, change detection, unit testing, and all that. So in terms, and even if you have done Angular before, you know that we have covered a lot of topic in last 30 to 32 hours. And these topics should be in your toolkit to write a proper Angular application. Today, you would be asked to fill this form. So all of you would get a URL right now. Please make sure that you fill this form very carefully. The 5 is the best and 1 is bad. In the training world, because I know there are many interns here, like 3 is considered as bad. So if you really don't understand any topic, anything for that, then start with 3. 2, 1 means your time is wasted. You haven't understood a single word. So why I'm saying that? Because in the corporate, you have to be very careful how you are rating. So 5 is the best, means you have understood everything. You are confident about that thing. And 1 means, oh my God, I sat there. It was of no use, right? So 5 is best, 1 is bad, and that is mentioned there also. Okay. Other than that, if you have anything to say which is not in that feedback form, feel free to tell it to me. Feel free to say it to Mahendra, and we would see that how we can make it better next time. So here in the chat, I am putting in the Zoom chat, I'm putting that link for you, and also you will get that in the mail later. But make sure to provide your feedback right there. Everyone, it is important. Please provide your feedback. Okay. So this is what from my side. Once again, my name is Dhananjay Kumar. Thank you so much. If you have any question, we can do that. If you want, we can do that 1 hour follow-up, maybe next week. If for 1 day, for 1 week, go and rewatch these videos and everything. And since you are team of Jacob Sir and Mahendra, I'm offering this to you that we can do 1 more hour, maybe next week. Whenever you have a set of questions, we can sit together and just answer that questions, maybe 10 questions in an hour. But you will have those questions when you go and rewatch these videos, when you go and try to run those source code and everything. This is my blog, debugmode.net. So this is from my side. Thank you so much. Best of luck, everyone. If you have any question, I'm happy to take it. Otherwise, over to you, Mahendra.
Okay, thank you. Tim, do you have any question for today's session?
No.
All good. Okay, so Dhananjay, I think we are good. Thank you so much for the training and the knowledge that you shared with us. We'll connect with you if there is any further question or discussion required.
Sure. And once again, thank you so much, everyone. Best of luck. Do good.
Yeah, Dhananjay, two more things. Please share the advanced training course with me. Whatever the final version you have.
I'll do that.
Yeah, and also share
I'll
PPT.
connect. I'll connect with you on the phone just after this call for 5 minutes.
Okay, and also share the PPT for today's session, right? The detection, change detection.
Yeah, I'll do that. I'll put everything and share. Okay. And thank you so much, interns. Do good. Okay. Best of luck.
Thank you.
Thank you.
Bye.
Thank you.
Bye.
Thank you.
Bye bye.
Bye.
Thank you. Bye bye.
Thank you.